Hello and welcome to ZaranTech. In today's fast-paced digital era, businesses need robust database solutions to handle vast amounts of data efficiently. Today, we're diving into SAP HANA 1.0 SP12. SAP HANA 1.0 SP12 is a revolutionary platform that combines a database, data processing, and application platform capabilities in memory. It's all about speed, efficiency, and real-time insights. In today's fast-paced business world, time is crucial. SAP HANA 1.0 SP12 offers up to 10,000 times faster data processing than traditional databases, enabling swift decision-making and a competitive advantage. With data reigning supreme, real-time analysis is invaluable across all sectors, making SAP HANA a transformative asset for businesses. In this course, we'll cover everything you need to know about SAP HANA 1.0 SP12. We'll start by exploring its key features and capabilities, followed by a deep dive into its architecture and how it differs from previous versions. Then, we'll walk you through installation and configuration. And finally, we'll wrap up with best practices and tips for optimizing performance. Before we begin, please make sure you subscribe to our YouTube channel and hit the bell icon for regular updates from us. Now let us look at the agenda. Agenda 1. Basic concepts of SAP HANA SP12. 2. SAP Business Objects Data Services. 3. SAP Direct Extractor Connection Overview. 4. SAP Landscape Transformation. 5. SAP Replication Server. Let's dive in.
So this unit is very much critical, and this unit, along with the next unit which we will discuss, will cover around 6 to 7 questions in SAP certification, and a very technical overview of this section should be suffice to enable you to answer these questions. So like one of the few examples are like, what are the different service offerings of SAP in terms of cloud, or what is HANA Enterprise Cloud, what is HANA Cloud Platform. So those kind of simple questions will be enable you to answer those kind of questions for the certification. So let's jump start with that. So what has happened in past 10 years is that there is a huge amount of data explosion in our world. Earlier it was only used to be an enterprise data, but nowadays we have the enterprise data like your transactions data, master data, inventory, along with the social data of email, mobiles, speed, sales order, and many more. If you see the left side chart, this is our reality of today's world. And there are huge amount of data sets floating, and the IT companies are not able to deliver. So in a conference in 2013, IDT, that is International Data Conference, estimated that the total data size of world is now 4 zettabytes. 1 zettabyte is equal to 1 million terabytes. And with 2020, the total digital data of the world will become 40 zettabytes. So that is something which we need to work out, and how a lot of companies are addressing their big data issues with their growing demand for data, and also to historically work on historical data to do the analytics. So in the last 2 years, if you see on the right side, you can see the KPIs and the factors that in the last 2 years, 90% of the data has been generated through various means of your GBS, email, ERP, CRM, inventory, planning, transactions, material management, master data, and so on. And we are expecting a growth of 40% in the next 2 years. So by 2020, 212 billion devices will be connected to internet and will be able to monitor the data from these devices through IoT. By 2020, 9 billion users will be using the mobile and will be sending and using the data on mobile as well. And one of the astounding factors was by 2014, 51% of the workloads are processed in cloud. So these factors give us that a huge amount of data has come up in the past 5 years, and there's a growing demand by all the organizations to grow their businesses and to explore the connectivity of the consumers and business partners, and to check and to work with various varieties of new data in real time, and to do a real decision making based on the latest data and the historical data. There is a huge demand for real-time applications and innovative applications that can work with this amount of data and can also provide deeper insight and proactive decision support for these companies. So this is just an illustration to show you how the data exploration is going on. So currently a lot of people will own terabytes of data, and you can see that a terabyte is 10 to the power 12, petabyte is 10 to the power 15, and exabyte is 10 to the power 18, zettabyte is 10 to the power 21. So 1000 exabyte, that is 1000 million terabytes will form 1 zettabyte. And by 2020, we are expected to have a 40 zettabyte of memory for the whole world. So apart from this, there are certain challenges that IT complexity is shifting its growth. And there are different types of applications like manufacturing applications, separate finance applications, sales applications, analytics applications, service applications, spatial, streaming, predictive applications. And all of these different applications are working on different databases, each having its own different ETL and staging tool, so that all of these applications are working on silos rather than working together. So one of the example is, suppose I have a very giant FMCG and they have the sales data. They also have another social data where they ask about the reviews of the product, or even a CRM data, and even the logistics data from the IoT. So instead of combining like the social data and the sentimental data, like which product they do like, so they can increase the inventory of this product. They can also increase the transport or the logistics part of the product so that the users get this product faster and they can make much more revenue in the product. So these application silos, they never interact with each other, and because of this, there's always a partial business view rather than having a complete picture. And because of this, we are not able to get real-time insights about the data, like which inventory should be moved faster, what is my out-of-stock options based on the social data, and also there is a limited ability to innovate. So going forward, SAP tries to solve this traditional problem and tries to bring all this data together and trying to reduce its complexity. So SAP is trying to build one platform for all applications. So all of these applications will be powered by one high performance platform. This means a common architecture with one store for all data regardless of the data type. And the data is available to all the applications in real time. That is no more data movement and no more management of multiple data sources. Each of this application will access the same data store, and each of this application will be accessing the real-time data. So this will provide us a less complex system along with very less redundancies, and it will also provide us with a complete business view and ability to react in real time and seeing that how the different applications can interact with each other in real time. So this is SAP HANA approach, where we have the traditional approach and we have the SAP HANA approach. But traditionally, the systems are optimized for transactions like OLTP or for analysis, that is from OLAP. So if based on the requirement, if I have a requirement that I need to do a more analysis on the data, then I prefer to have a OLAP system. And if I have requirement of point of sale or more data inserts, then we prefer to go for an OLTP system. For your reference, OLAP system is called as online analytical processing and is mainly optimized for a very faster read. But an OLTP system is online transaction protocol where it is mostly optimized for writing the data. The transactions are managed in a system with the hardware architecture and database design, and data models are built around the faster read or write at the record level. But the OLAP system or the analysis system takes on a different approach. The hardware, the database, and the data models are built around batch loading, aggregate storage, and a focus on read-intensive queries. So basically your joins operations, aggregations will be faster and much more optimized for an OLAP-based system. But SAP HANA takes up both the best features of OLTP and OLAP and combines the transactions and analysis system to perform an unprecedented speed for reading as well as for the writing scenarios. Okay? And the database, the hardware, and the data model, that is the data stored in SAP HANA, are built for combined transaction and analysis process. There is no movement of data between your secondary storage to RAM, and hence there is a very faster read access. And with the insert on delta concept, there is a very faster write in the database as well. Now the question comes that how can one platform handle all applications, and why we did not do this earlier. Earlier we were having a 3-layer architecture where we used to work on lower capacity CPU and a very limited memory of RAM, and a majority of the data used to be in disk. And during this 3-layer architecture, whenever an application requested for data, the data from disk used to come up to a RAM layer, and from the RAM it used to go to CPU for processing, and then from CPU for after any calculations it used to again go to RAM and then given to the application layer. But imagine the same can be performed by the RAM, and instead of movement of data, RAM itself can handle the calculations and give the results to the applications without doing much movement of data. So what we have got is the technological enhancements like multiple cores per multiple CPU for your faster computation, and a huge memory like up to 2 terabytes or 3 terabytes of RAM for loading all of the data into memory. So historically the high cost of memory was one of the reasons that only a small amount of memory was available to use, and it did not matter that how fast the processor was, if the data can reach out to it quickly, but we had a very limited set of data to move. Now in today's world we have there's a huge reduction in memory, and even in our cell phones we carry up to like 128 GB of data, and we can very easily use 128 GB of data in your lot of architecture supported CPUs in today's world. So memory is no longer the bottleneck. So to address large amount of memory, we need a 64-bit operating system, and 64-bit operating system provided a larger bus size of 2 to the 64. That is around 2 terabytes of data can flow in 1 second with the bus. Apart from this, there is a lot of enhancements for CPU that the processors continue to improve at a phenomenal rate. Now we have multi-core processors inside the same CPU compared to earlier single-core processor. This multi-core processor can provide parallel processing and a very faster rate of execution. And this is about, I'm talking about having 10 cores on one CPU. And in case of a blade server, we can have multiple CPUs on the same board. So it will be like 8 blades will be available on one single stack. And all of this will work in parallel to give the total computational capability of 8 into 10 cores. That becomes 80 cores per blade. So apart from this, there were certain advances like your design on the cache, onboard cache. That means the data can pass between memory and the CPU cores rapidly. So in the past, even with large amount of memory, there's still a bottleneck because the CPUs were demanding more data and the speed at which the data can flow from memory to CPU was less. So now we have a very faster cache memories and a much more larger size of the cache memories to enable most useful data closest to the CPU. Also, along with this, we have the various architecture scenarios like scale up and scale in, where we can enhance the size of the total RAM and the CPU capabilities, and also that is called as scale in. And we can also add number of blade servers to enhance the total distributed capability of HANA system, where one server can act like a master, another server can act like a slave servers. Now, because of this, there are a lot of different gains, but the traditional database and applications were designed for old and restricted architecture. That means they needed a lot of software innovations along with this hardware innovations and hardware changes. And the business software went from a transformation from on-storage memory to an in-memory storage, along with enhancements of cloud storage, enhancements of your row and the column store, compression, partitioning, insert only on delta, and no aggregate table. So based on this, the hardware and the software innovations, SAP was able to come up with a new product that is called SAP HANA. And SAP HANA was sold along with the various hardware partners like IBM, Fujitsu, Dell, Cisco, NEC, who provided this different hardware like multi-core architecture of 8 CPU into 10 cores and a 64-bit address size, and along with a huge memory of 2 TB to 3 TB of RAM. So these are some of the technological drivers which you see that from like 1990 till 2010, the CPU was enhanced by 143 times, and the memory was also enhanced by 250 times. The addressable memory, that is the bus size, became from 2 to the power 16 to 2 to the power 64, that is a 64-bit operating system, and total enhancements of 2 to the power 48 times. The network speed also was enhanced from a mere 100 Mbps to a dedicated line of 10 gigabytes per second. So there's an enhancement of 100 times on the internet speed, along with the data to disk transfer rate of 5 Mbps to 130 Mbps with an enhancement of 25 times. So this is about the hardware and the software innovation. So we'll talk about the software innovation in the further slides. Before that, I would just like to show you that what are the changes between the old traditional analytics and the new in-memory database analytics. Earlier, if you see on your left hand side, earlier we used to have different databases to capture the data, and data used to be in your ERP system applications as well. Now from this databases, we used to create an operational data store, ODS, and replicate the data using ETL into a data warehousing component. Once we have got the data into data warehousing components, we used to create indexes to read the data faster, and also create an aggregate tables to calculate the aggregates before the query. So just a quick, are you able to see the traditional versus in-memory analytics comparison?
Yes.
So what I was saying that the data in the enterprise business application, the POS data we used to be in your ERP system, and from the ERP system we used to create an ODS, that is operational data store, and on this ODS we used to first bring the data or a smaller set of data into our data warehouse using an ETL. Once we have got the data into our ETL, the data store used to be indexed for a faster reading, and aggregates were created for these tables to get the design time aggregate so that my query performance is not hit at the runtime. And at the last, we used to have a calculation engine and to perform the result of the query, and the analytics was given on top of that as part of your business intelligence. So there was a lot of latency between the data creation in the database till the analytics uses, and many different flows like ODS, data warehouse, indexes, aggregates, and many more things were created till the final data could be consumed finally as part of your business intelligence. And it also demanded a different kind of infrastructure as together, and installation of various components like the BWA, BW, then your different ERP system, then PSA, and a lot of configurations for that. But coming to in-memory data analytics technology, different layers between the analytics interface and the data has been removed. And there is only one component that is called as in-memory analytics, which comprises of various engines, various data stores, and the various processes. And the best part is that a lot of these operations, a lot of these configurations are automatic, and user need not bother about those things. Like index creation is automatic, partitioning, you can very easily configure the data. Only requirement was to have the data in ERP applications and copy that into your in-memory database and consume the reports on top of this in-memory database. So there are no optimizations required, no aggregates, no index tables required. All other data query can be done on the real time, and all the calculations were done on the fly.
So how about the traditional, we are using the Informatica or any ETL tools, right, or bots. We are having a lot of complex transformation and aggregate and data quality. All those things we are happening right now in traditional model. So what about in the SAP HANA model? You're saying just replacing the in-memory analytics. We are dumping the data in the RAM. But what about the data quality and all those validation will come into picture in in-memory analytics?
Yes. So for that, there is a different component that is the HANA quality, and through the one of the different methods, like SAP HANA has its own data provisioning methods, like smart data integration, SDI, and smart quality integration. So using this, you can do a very strong data manipulation, data cleansing, and directly bring the data from your ERP system or BW system or any other source into HANA. But along with that, I'll say that boards is one of the important tool where you can connect with different sources, 108 different types of sources, and bring that data into HANA. So, but as I said, HANA is also growing on building on its own data provisioning tool from using SLT and using smart data integration. So does it answer your question?
Yes.
Okay.
Thank
So
you.
let's continue for the next part. So I was talking about that these are the various technology drivers in the past 20 years where the CPU has been enhanced by 143 times, and memory also has become cheaper per dollar, that is around 250 times. The bus size has also increased by 248 times. Network speed has increased by 100 times, and the disk to data transfer rate has increased by 25 times. So what we'll see at later this is what are the various SAP HANA software innovations which were clubbed with the hardware innovations to give a faster reporting and analytics. So the first one, basically these are the first hardware innovations like the different methodologies or the technologies for the secondary storage like solid state device, flash device, or hard disk were used compared to the spindle based hard disk, which are much slower. And in memory, there were different technology improvements like row and the column store, partitioning, compression, inserts only on the delta, and along with the CPU, there are multi-core CPUs multi-cores per CPU, and they were all housed in a blade server, and you can have multiple servers attached to each other to give a very high parallel processing. So the first comes the data stores. So SAP HANA is both a row store and a column store. That means it supports not only the data to be stored in the row format, which is a traditional RDBMS format, but also to allow the data to be stored in a columnar storage. So what do you mean by a columnar storage? But if I see from my top left, I have a table which contains some first three columns. One of the column is text A, B, C, D, E, and the column is a numeric 10, 35, 2, 40, 12, and third column is having a currency symbol. So when this data is stored in traditional RDBMS in a row store format, since the data is a continuous memory allocation, the first row is inserted in a page, and like example is A10 euro. Then after that next memory space, the second row is stored like B35. You can see that by your second last organized by row data set, and the third row C2 euro, and the and the fourth row that is D40 euro, and so on. So this is how the traditional database will store the data when it is in the row format. But because of this, there are a lot of inconvenience and reads cannot be faster. This is good for a very high speed write intensive scenarios or an update scenarios, but not good for an OLAP scenario, which is basically a read intensive scenario. So what SAP has come up is a concept called as columnar storage. In this concept, the data is stored a column by column rather than row by row. So if I see the last image that is organized by column, we can see that first a complete row, that is first a complete column like A, B, C, D is stored, and then all the numeric data of the second row, second column, that is 10, 35, 2, 40, 12 are stored, and then the third column of euro, dollar, euro, dollar, euro, dollar are stored. So this is how the data will get stored as a columnar storage, and on top of that is different concepts of inverted index or double inverted index, and how the data gets indexed out of the storage. So what are the benefits of storing the data in the traditional, conventional, compared to a conventional data source? So storing the data in the columnar enables a faster processing of the operations such as an aggregate. Example in this case is, suppose if I want to take an aggregate of all the complete second column. So in that case, if I have a columnar storage, I know that where my second column starts, that is from the memory location of 10 till it ends till memory location of 12. So I need not read the whole table, but we can just directly read the addresses and the values from 10 till 12 and combine them. So my aggregates are much more faster compared to a traditional data source. In a traditional one, I will have to start from the initial table scan and do a complete table scan just to do an aggregate. So I need to go first find out 10, then I need to go find out 35, then I need to go find out 2, then I need to go find out 40, and then I need to go find out 12. So once I have found out all these things, then I'll do an aggregate and send the results. But this process has asked me to read the complete data set, which is much more time consuming. Now imagine this with millions and millions of records. So when you have millions and millions of records, so we cannot afford to have a time wastage on reading complete table scan when only a few memory locations can be read for the aggregation. The columnar layer also supports sequential memory access compared to a complete table scan. So we can know that all the texts are present from A, B, C, D, E, and all the numerics are present from the memory location 10 till 12. So based on this, we can assign different threads or different processes from different servers to work on the same data set. So in short, I can ask the slave server to work on first column, or I can ask the second slave server to just work on the second column of the numeric data type. So these are some of the benefits what you can get with your row store and the column store. So SAP HANA process can process both row store and the column store. So when do we use a row store or a column store? Mostly a row store is used when we have a very distinct values in the source database, and that will enable us to have a lower compression. Compared to this, a column store will be used when we have a large number of rows in which a lot of duplicate values are present, like your master data, where you have employee name, employee number, or material number, and a lot of repetition of address, lot of repetition of city and the country, and a lot of different codes. So in that case, it will be much more helpful to use a columnar storage compared to a row store. The row store is supposed to be used when we want all the columns of the tables in the query. Suppose if I say select star from employee table, so it makes much more sense to use a row store because I'm bringing all the columns of the table and reading them, all the columns in the table compared to specific columns will be faster in case of a row store. Suppose we have only selective columns to be picked from a table, then we can go for a column store, and it will be much more further optimized for this query. Column store is mostly used when we have large number of columns and more compression or more duplicates can be achieved. A row store is used when no aggregation or a search is required. So aggregations and search are much more faster in a columnar storage. Also, the row store is more applicable when you have less number of records into your system and we do not need to read on the records frequently. So some of the system-based tables are into the row storage, like your time, your different schemas, what are the tables which are present in the schemas, some statistics and so on are in the row store. So one of the reasons for this system tables to be in the row store is that it is much more faster to write into the row store, and hence the system needs to perform different statistics and calculate these statistics at a very fast rate. So for this reason, some of the system-based tables in SAP HANA are row store. Columnar storage is more applicable when we have a faster read or an OLAP requirement. The row store is mostly used for a OLTP requirement. So what are the other benefits what you get? Yes, please tell me.
One question, sorry. So, HANA supports both row store and column store, right?
Yes.
Okay, so that for OLTP, so HANA can be used for OLTP transaction as well as OLAP.
Yes, both are done for OLTP and OLAP. For the both the stores are done for OLTP and OLAP.
Okay, and what about the if it's a column-based store? So what about the data model? So currently, our data modeling desktop of row storage, the physical model is going to change, right? So it's in the architecture.
So based on a data model, your column store will provide you much more better results. And suppose one of the example is like when you want to have the transactional data, so which is constantly getting updated or constantly inserted, better to have it on the row store, and all your master data, which is like quite huge and does not get updated very frequently, to be used as a columnar storage. So from a table perspective, you'll not find any difference, but internally the processing, how the aggregates are calculated, how the search is done on the tables will be different for different store. So we need to take a very conscious decision over here that which data should be used as a row store, which data should be used as a columnar storage. So, but for smaller data sets, the performance of both row store and the column store are same. So we should not be worrying too much if you are dealing with smaller data sets like in thousands. But if you have a huge data sets and there is a very complex join which will create millions and millions of records, then we should think about the columnar storage. Now the next concept is your compression. Now with compression, when we say you would have known about different types of locks in a DBA, that is your table lock, your column lock, and your row lock. Whenever I am reading the data from a particular row in a table, then there's a row lock applied on the table. Now, even this, when the data is partially blocked, we can have a huge amount of compression in memory database. There are different algorithms which are present in the SAP HANA, which will automatically compress the data based on the data which is present in the tables. So one of the examples is, suppose we have a customer, country, product, and amount, and based on the number of duplicates in the data, so an indexes is created, and based on the indexes, we can see that how much compression can be achieved for the particular tables in HANA. So when we say about, in this example is like we have customer, country, product, and amount, and you can see that for customer there is a duplicate of 100. So we can always, SAP HANA will eliminate that and keep that information in your data dictionary as only as 100, 200, and 300. Similarly for country, it sees that D is a duplicate of another entry of D, US is a duplicate, or the fourth row is a duplicate of the US country code. So we can achieve a target of 50% compression over here because we have two duplicates. For the third column, that is your product, we have two duplicates. So out of 2 out of 4, we can achieve a 50% compression for product. And even for your last column, which does not have any duplicate of data, but it can still be optimized and compressed based on the similar data sets, like it is an integer, so it can occupy 32 bits. Next entry is also an integer, so it can occupy 32 bits, and it can also occupy the previous unallocated memory in the 32-bit of integer. And in a similar way, if the data types are similar, then we can do a compression on a column which does not have a duplicate value. So even in this case, the compression is possible, but it will not be too huge, but still a substantial contribution to the overall compression of data. So in the next class, when I connect with a HANA system, I'll show you that how the data load happens and what is the in-memory size of the data node, also how the compression has happened and how the compression has resulted in reduced size. So this is the way the data is stored for a columnar storage. So this for a row store, sorry. So column 1 data will be at some memory location 4, then column 2 data will be at offset, next offset, that is of offset 8, then again, and like this wise, the continuous memories will have different row by row data sets. This is a diagram for bitwise offset for a continuous storage or for a columnar storage. So all the column 1 are stored together, then we'll go for column 2, column 3, and so on. Now it's coming to the partitioning. Since we can have a scale-out architecture where we can have different nodes in the system, or even we can have a master-slave in the system, and let's assume that there is a distributed system. So what is a distributed system means that the system, overall HANA system, is spread across multiple databases, which has some component is database as master DB, another component is your slave, and the third is also a slave server. So based on this, when we have a table which is a columnar storage, so we can partition this data and assign one column to one blade, and by this different columns can be assigned to different blades. So you can see here we have table 1 and we have 3 blades. So each of this table has different columns like A, year B, and year C, and so on. So once we have configured that, what you can see that a table 1 column 1 or table 2 column A, table 3 column A, table 4 column A, all the columns of the different tables are handled by one core. Another core will be responsible for all the second columns in all the tables. Okay, so this is called basically a partitioning, and there are different methods of partitioning: round robin, hash, range partition, and based on the requirements, the basis admin will do the partitioning of the data. And even this is also required when there is a huge surge in the performance of the system because of some data which is quite huge and which gets loaded into the RAM, and or join operation on two tables is resulting in a huge amount of data, and which cannot be controlled by directly through single core of the server. Now the last enhancements in the terms of technology was insert only on delta. Earlier, HANA was criticized to be an OLAP database where it provided only a faster read of the data. But with this concept of insert only on delta, SAP claims that the inserts or the edits in the data sources are also quite fast in HANA. So how does HANA implement that? If you see at the diagram in the center, you have main and delta. So SAP HANA keeps us two components of memory, that is, one is main memory and another is delta memory. The main memory basically contains the complete data in a compressed format, in a columnar storage, in a sorted format. But the delta contains two parts, that is delta 1 and delta 2. So delta 1 is basically your columnar storage but is not sorted, not indexed, and your delta 2 is your row store. Now my reads can be done on both main memory and as well as the delta columnar storage memory, but my writes can only be done on my delta memory. So whenever there is some table to be inserted or some values to be inserted, so it will be first going through the row store. Once it has gone to the row store and the replication either has stopped or there has been no more changes on the data, then this row store data will get converted into a columnar storage. through the transformations. And this, just note that till this time indexes have not yet created. Then after some time, it will asynchronously merge with the main memory, and the main memory will get the latest changes of the data, and it will get indexed and further compressed. Now it provides a dual benefit that during a read, when the lock is present on a table, this lock is present for a table which is present in your main memory, and the copy of the table is free to receive any inserts or any change data capture through your delta 2. So my inserts are also not waiting for the lock on the read lock on the table, but also it enables to write the data on the same table and get merged asynchronously. Regarding the hardware innovations, regarding the software innovations, and how SAP HANA solves us real-time problems. What is the roadmap for SAP HANA? You can very clearly see that SAP wants SAP HANA to be database for every ERP application and to run on a single host rather than having different data stores.
All right, let's test your knowledge. Here's a question for you. Which of the following is a key feature introduced in SAP HANA 1.0 SP12? Option A, advanced data compression. Option B, dynamic tiering. Option C, smart data integration. Option D, single container multi-tenancy. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, ready to dive into the world of SAP HANA 1.0 SP12? Our course is your ticket to mastering supply management. You can learn at your own pace, right here on our platform. In this course, we will unpack SAP HANA 1.0 SP12, the ultimate toolkit for planning everything, from ensuring we have got enough products to get them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors? They are pros with years of experience, dedicated to helping you learn and answering all your questions. And guess what? Our students love it. Just like you, they have found our course incredibly helpful. The best part? It's super affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA 1.0 SP12 Pro? Sign up on our page now. For more info, visit ZaranTech's website.
Yeah, so we have discussed about using HANA as one platform where you can bring all the data, all of your complete ERP data into one system, and you'll be able to access the same data across all the systems by using the same database. So the advantages what we get over here is you can get a complete business view, a very minimal landscape is required, and it reduces the complexity of the landscape as well, and also the data can be very easily used across the different departments. So in this case, the most important critical slice of information can be delivered in the real time rather than bringing the data from ETL methods from different sources into HANA. Okay, so after this we had seen the traditional approach where the OLTP is a separate approach and OLAP is a separate approach in a traditional environment. But SAP HANA combines both this approach as a transactional and analysis in one single HANA database, which can also be used for faster inserts for OLTP and a very quick read on the database for the OLAP database.
Right.
So some of the advantages we have seen in the technology where how the hardware innovations can be used to increase the innovation capabilities of today, and how this like memory, increase in the memory size, increase in the multi-core processing of the CPU, increase in the disk speed has resulted in the hardware innovations on which SAP HANA was built. So the computer architecture has changed a bit in the recent years, and multi-core CPUs on one chip in one package are standard solutions now, and extremely fast communication between the processor cores enable parallel processing. So this forms like one single blade server, and multiple blade servers can be added. So what you see on the right side can be on single blade server. The blade server sizes can increase from your 2 terabytes or 256 GBs to 2 terabytes. The main memory is no longer a limited resource. The modern servers can have 2 terabytes of system memory, and this allows the complete database to be held in the RAM. Now the big data concept, which was earlier 4 terabytes of data, which was in secondary storage, now could be held in the RAM and will enable a faster data read and faster data processing. So till now we can have a total CPU core of 64 cores, or till 128 core processor will also be available soon. So that will give around 128 times the faster processing on the data compared to the traditional CPU, the traditional architecture. Also, one of the hardware innovations what we get to see is the speed by which the data is read between this disk and the RAM, or the input-output read, which is that is also increased by the 64-bit bus size. So 64-bit of bus size will give you a total increase of 2 terabytes per second. So 2 plus 64 will be 1 TB. Okay. So this is a traditional and the in-memory analytics comparison, where how the data used to come from a traditional sources from your enterprise business application, and then it was copied as an ODS or the operation data store. Then through an ETL, it used to go to a data warehouse where the indexes and separate aggregates were created, and then furthermore there was a latency between these aggregates and the final query result. This was a bit expensive infrastructure, and there was a quite duplicacy of data and slow performance of the query result. So SAP HANA came up with an in-memory analytics which resolved all of these issues and also enabled your data to be queried in RAM compared to creation of indexes, creation of aggregates, and creation of data warehouse, then doing a calculation engine performance in your application layer. So all of the decisions, all of the calculations were pushed down to the database layer, and only the summarized result set was sent to the application layer. So this enabled up to 100, almost 1,000 times faster data processing. External optimizations like creation of aggregates, creation of data warehousing, 3NF form were not required, and more data could be achieved in the less space because of the columnar storage and huge partition involved, and there was a faster business intelligence which could be done with the in-memory data analytics technology. Now coming to this is some of the technological advancements. We have seen that historically the database systems are designed to perform well on computer systems with limited RAM, and hence all the data was stored in secondary storage, and there was a slow disk input-output read was the main challenge for the data throughput. The architecture of these systems were designed with a focus on optimizing the disk space rather than on optimizing on the speed and also the read capacity from the data. So there were some of these technological innovations like the CPU processing capacity increased by 143 times in just in a span of 20 years. Memory became very cheap. In the same dollar, you can buy 250 times of memory. Nowadays, people use 16 GB, 32 GB, 128 GB of ROM in iPhones and other devices. The bus size was earlier 16-bit. Now we have a 64-bit. Every machine has 64-bit bus size. Even your cell phones are now 64-bit machines. So this gives us a total external memory allocation of 2 terabytes, and 2 terabytes can be moved from your secondary storage to the main memory using the high bus size. Also, the network speed has increased from 100 Mbps to 10 Gbps per second, and we could see an improvement of 100 times over there. So earlier we used to have a very dedicated internet speed of like 100 Mbps in your office or in your other places, but now your data centers have dedicated 10 gigabytes per second. That is, in 1 second you can transfer 10 gigabits. That is almost equal to like a 1 GB movie can be downloaded in 1 second, or in fact less than that. The disk to data transfer, the speed by which the data is transferred from your disk space, that is your secondary storage, to the main storage, that is your RAM, is increased by 25 times. Hence, there was a very less input-output bottlenecks. The CPU was able to process the data much more faster, and it need not wait for that. And some of the hardware innovations came from the hardware partners, like Intel built a separate CPU and the architecture for SAP HANA, that was Intel's Westminster Bridge, and that enabled faster reading of the data. So let's quickly just go through that. So a quick question, what is a column store?
Yeah. Column store, right? If you normally the traditional database are storing in the row ways, but when the HANA SAP HANA, in order to retrieve the data quickly, the data are stored in the column wise.
Okay. So what is the need? Why is the column store much more different from a row store?
Yeah, so that for the column level, right, for the first column will be distributed in one core. The second will be, so the column store will be distributed across the nodes or into the data, the parallel processing.
That's
the
correct.
Retrieval, yeah.
So one of the main benefits for a column store is your parallel processing. That is definitely correct. But what are the other benefits what we can get in terms of an OLAP?
OLAP, so sorry for that. I'm not able to answer.
Okay, so no issue, not an issue. So the column store, when we store the data column wise, it is very easy to read on the data and perform aggregates. Suppose in this scenario, if you see the table on your left side, you can see that you can do a summation of all the rows of the second column, like 10 plus 35, 2 plus 40 plus 12, because I know that my 10, the first value starts from this location and it ends at this location. Okay, so we can very easily do a calculation if we are doing a data store as a column wise.
But the column store will be more useful for the OLAP, not for the OLT.
Yes, definitely. And a row store is more useful when we have very high intensive inserts or write statements into your data. The reason for that is the data can be very easily inserted in a row store. The data could just go at the end of the tree, that is till the data is stored, and it just has to insert the one record, one whole row at the end of that. But in case of a column store, the data is broken. The data is indexes which are created on this data are broken. Then the data is adjusted. Suppose if I insert another row, which is the value is F20 and euro as the 6th row, then I have to go at the end of the E in the last, if you can see in your last diagram, and after that I have to insert F, then after 12, I have to insert 20, and after dollar, I have to insert a euro. So I have to re-break the structure, re-break this dictionary, rearrange them and index them, then sort it out and so on.
In other words, we can tell for the row level storage, row-wise storage, the write speed insert update will be faster.
Correct.
Right, and the read compared to the column storage more faster in reading a data.
Correct. So the speed differences between the row store and column store will not be visible much when we have a very less amount of data. This will be very much visible when we have a big amount of data. Let's assume like 10 million records. Okay, and this 10 million records, when I'm doing a join, it's another 10 million records. That is around 10 to the power 6 into 10 to the power 6. That will be around 10 to the power 12. That is equal to 1000 billion records. So that time my read column store will be very much beneficial, because that time it will provide me a much more faster read compared to a row store. But at the same time, row store provides me the advantages of having a faster write. Okay, some other databases from SAP, which is a column store, is your SAP Sybase IQ, and this concept has been available in the market since 1999, and column store was mainly used for analytics and data warehousing, where the aggregates play an important role. Okay, so but with HANA, we could even get the row store and a column store in the same database. Earlier, the database only could be a row store or it could only be a column store. But with HANA, we can put the data in both the formats. Okay, that is the row store and the column store. And the developer needs to specify whether a table is to be stored column store or row store. And it is also possible to alter an existing column store to the row based or to a column based on the scenario. Suppose your business says that, okay, earlier we'll put the data as column store, but after some time you see that there are a lot of huge inserts happening into the system, then you can decide to change that table as your row store.
Is there any limitation in column level store? For example, if I am having a 256 column, is there any limitation of column store?
Yes, it will have certain table restrictions that will be present for all the other things. One of the restrictions is like you cannot have more than 256 columns, first of all, whether it is row store or column store. Okay. Second of all, you cannot have more than 2 billion records in a table, one table. So if you have more than 2 billion records in a table, you need to partition the data and store that data into multiple tables or into multiple servers. So when do we use a row store and a column store? Can you just briefly explain? Let's take an example. I have in my system where a lot of transactions are coming up in my system. Okay, so what should be my preferred way of storing the data?
Sorry, come again, Abbas. I missed that question.
I have a lot of inserts coming up in a table through my IoT device. So let's assume my IoT device is sending 100 records per second. Okay, so yeah, so in just 1 hour, it will accumulate 360,000 records in the system. So which data store type I should choose for this kind of
row-based store is better, because while inserting records, huge insert, row store is better.
Okay. Now let's take another example. I have one table which has around 100 columns in that. Okay. And at the runtime, I'm just fetching the data only from 10 columns. So which data store should I choose when I have multiple large number of columns and I select only few columns out of this?
Column-based store is better than this.
Great. Okay, let's take another scenario. I have a master data in which there are a lot of duplicates like your customer-based information or products-based information where the shipments can be to the same city. Multiple products can be shipped to the same city. So what kind of storage I would prefer over there?
So come again.
If I have master data kind of arrangement where a lot of data is duplicate, like your product data and product shipment data, and the different products can be shipped to the same country, same city, and same places. So what kind of data store I should be using for a master data where I have duplicate records?
Yeah, okay. So internally, it needs a lot of insert, right? So
no, maybe not. It is possible, but usually master data will not have much inserts, or very inserts will happen at not a very frequent interval.
Yeah, it's a dimension table, right? Okay, then it'll better you go for a column store.
Definitely. Okay. So even for the performance based, so we know that column store provides much more potential, faster execution speed. Okay. So there are also background processes which enables column store to be much more faster, like SAP HANA works with bit encoded values and compressed repetitive values from the data dictionary, which results in much more less memory requirement than for a traditional row store data. Okay, bit encoded values and high compressed repeated values. It just works on the memory location rather than on the actual data for the processing. It just works on the memory location, and hence a very less memory requirement is for one complete table scan.
Okay, so one more question comparing with Teradata. So Teradata, what they are doing a compression, column compression, and table level also they are doing compression. So similarly, in SAP HANA also there is a compression concept is there?
Yes, definitely. So we'll see that today. So this is a concept which I wanted to discuss. So SAP HANA has a huge amount of compression. So compression also is required because since the data is present in your RAM, and RAM is quite costly. So whenever you want, you can expand your hard disk to increase the hard disk from 1 GB to 1 TB to 10 TB, and it will not take much cost. But when you want to expand the data in your RAM, the RAM is quite costly. So you cannot expand your RAM much more, and also you would need to bring the whole new CPU and whole new chip and put your RAM chip on top of it. So SAP HANA comes with a concept where the data can be hugely compressed in the data. This primary compression is basically a dictionary encoding of columns. Okay, and secondary compression comes up, which is the attribute vector of the column. So there are several algorithms which run and which include the compression, are like level encoding, clustering, prefix encoding, and this in turn reduces the size of the attribute vector. One more thing is the compression is not kept at a very high factor because SAP HANA plans to reduce the memory footprint, but it also does not want to compromise on the performance, and hence all the compression algorithms are basically your scan and cache friendly. Now, how does actually the compression happens? Let's take an example over here. Suppose you have a data, what you can see in your left side, you have customer, country, product, and amount. And if you see closely, your customer has all of this data has repeated value except for the amount data. So when I store this data in my HANA store as a column store, so the dictionary compression will happen. So how does the dictionary compression happens? Okay, so once the data is stored, you can see the customer has duplicate data. So once this data, the column store level data of customer is stored, then the system will automatically check what are the unique values present for the particular column. Now, if you see closely, you can see that there is one duplicate value of 100. Now, when this data is mapped with a distinct column values in your data dictionary, so instead of storing all 100, 100, 200, and 300, it will just store 100, 200, and 300. Yes, so we can achieve almost a 25% compression over here. Okay. Now, second is if you see country, so how many duplicates are there?
US, yeah, DE, 2 duplicates. Two
duplicates. So out of 4, I have 2 duplicates. So almost I can get a 50% compression over here. Okay.
Yeah.
Similarly, is the case for product. In product, I have 1, 1, 1, then 2. So there are 2 duplicates. So I get 2 divided by 4. That is almost 50% of compression. In the third one, how many duplicates are present?
Yeah, the fourth one, right? Amount column.
Sorry, fourth one, there is no duplicates. Correct.
Yeah.
So now this is true because in fourth one, I do not have any duplicates over there. So I do not get much of a dictionary compression over there. But I get another level of compression over there that is called as advanced compression, where each column can be further compressed using different compression methods like prefix encoding, RLE, that is run length encoding, cluster encoding, sparse encoding, and indirect encoding. Okay, and hence this data, which is also very distinct data, can also be compressed by these different methods. Okay, so in short, what we can say that we almost get a compression factor of around 6 to 7 times in a very structured data. So the compression factor for the second column is 50%. Okay, so this is calculated by the ratio of uncompressed data size to the compressed data size in SAP HANA.
Okay, so while compression, right, if HANA is doing the compression, and while reading the data, so that uncompression, right, you need to uncompress the data. So uncompressing, it will take some time, right?
No, it will be quite fast. So one more concept comes up, like compression only happens when there are more than 10,000 to 40 rows in the table. The number of rows increase or decrease by a factor of 1.75. And also, it will also happen if there was no delta merge for the last 24 hours. Then only the compression happens. So these are the certain things. There are algorithms, and you can put your cost function parameters over here, and also define that when the compression should happen, and database SAP HANA will automatically uncompress the data based on that configurations, and it will retrieve the data. But these are quite fast, not an issue, because we are having all our data in the memory.
So the compression will be managed by the administrator, or it will be automatic? It's a default one.
It can be. It is by default, and it is automatically calculated. Okay, and it is part of a delta merge operation. So we'll check when we understand the delta merge. So it is part of your delta merge operation, and if we create an empty column table, no compression is applied. But once the data comes up into the table, SAP HANA will start analyzing the data, and the delta merge will start executing. The data compression is automatically re-evaluated all the time and again optimized. Yes, we can do a configuration of that parameter, that okay, when it should get compressed, how it should get compressed, and so on. That can still be done.
Mm-hmm.
Okay, we can also see how much is the fully loaded column table from a system tables, and understand that what is the size it has taken, what is the table name. So there is a system table that is called as m_cs_tables, where you get to know that what is the data size the table has taken up, what is the main memory, and what is the delta memory over there.
Hey there, ready to dive into the world of SAP HANA 1.0 SP12? Our course is your ticket to mastering supply management. You can learn at your own pace, right here on our platform. In this course, we will unpack SAP HANA 1.0 SP12. the ultimate toolkit for planning everything, from ensuring we have got enough products to get them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors? They are pros with years of experience, dedicated to helping you learn and answering all your questions. And guess what? Our students love it. Just like you, they have found our course incredibly helpful. The best part? It's super affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA 1.0 SP12 Pro? Sign up on our page now. For more info, visit ZaranTech's website.
So once you get a server access, I'll show you all this information into the server. Now this is how the data gets stored into your bitwise. So we have already seen this information that how this is when the traditional data gets stored into your row store format. Okay, so we have first column, second column, then second row header. Then after the continuation of after the column 2, we have the second row's header, then second row's column 1, second row column 2, and after that we have third row column 1, third row column 2. Now compared to this, when we have the columnar storage, so we have first column header, then the next data set is for the column 1 data, second row of the column 1 data, then the third row of the column data, fourth row of the column data, and so on, till all the data for the column is inserted into the dictionary, and the next column will start getting inserted. So this is how the data gets stored into your dictionary and stored in the different .dat files, .data files.
Is it looks like in Oracle traditional database, in Oracle data, they are doing the indexing, right? Cluster index, non-cluster in Oracle, the DBA is doing. Similarly, the same concept is also there in HANA database.
Yes. See, the HANA is also database. So the same concepts of storing the data, paging, or all these concepts will remain the same.
Okay, only they are difference in architecture. They are considering the column level storage compared to the very traditional thing, right? So they are deviating from right row to column.
That is one thing, and also how the data gets stored. Where how does your actually the data are basically column store will provide you much more other benefits like high compression, partitioning, and so on.
But definitely there will be a drawback in column level store, right? If the traditional database they are following row level.
So inserts are a bit difficult. So inserts will take much more CPU in a column store compared to your row store. And every time an insert happens, the primary indexes which are created are always to be broken and again recreated. So heavy inserts on a column store is not advised.
Okay, which means this design, for which scenario I need to go for row store, which scenario I need to go for a column store, defined by the architect or by the developer, right?
Yes, by the business analyst or by the architect. So you can choose like based on your scenarios. Suppose if I want a better read, then I will go for a column store, and if there are very less columns are selected, then we'll go for a column store. If the table has the table has large number of columns, then we'll go for a column store. Then if the table number have large number of rows and the columnar operations are required like aggregate, scanning, and so on, and high compression is required, then we go for a column store. So based on this kind of intuitive calculations which you do, you have to go and take a decision. And suppose in that case, in your decision is not decision is not supported, and at the later point of time business wants to change the data type storage, you can always write a query like alter table, alter type, and you can change from a row store to column store or vice versa. Other thing is your partitioning. Okay, so how the partitioning happens in the data and what is the need of a partitioning. So partitioning feature of SAP HANA will split the columns store tables horizontally into sub-tables or partitions. Okay. In this way, what happens, the large tables can be broken into a smaller and more manageable data sets, and this smaller data sets can be accessed by different servers. I had explained on that day about the distributed server, right, where you have multiple servers, blade server attached to each other. The first server acts like your master server or the master server, and the other server will act like your worker server. So once we have a columnar storage, this smaller data sets can be accessed by the slave servers, and I can do a faster read on the table because my parallel processing can happen on the table. So this is very much a good feature when partitioning is mostly used in a multiple host system, that is in a distributed environment. But it can also be helpful for a single host system. Different advantages of partitioning, like you get load balancing, that suppose if I'm reading on a table and that table contains 10 million records. When I'm reading a complete table of 10 million records, I'm engaging one of my threads to load that 10 million records into the memory and work on that 10 million records. But imagine if I split that 10 million records into 2 million, 2 million, 2 million, and rest is your 4 million records, then I can say that each 2 million of records can be accessed by a separate server, and hence the performance load on each server is reduced.
Yeah, basically we are distributing the load across the server's node.
Correct. That is the load balancing. Okay. Now, second is, I told that there is a limitation of the table cannot have more than 2 billion records.
2 billion?
So 2 billion records cannot be present in a table. More than 2 billion records cannot be present in a HANA table.
Limitation. Okay.
Yes. So we can overcome these limitations by distributing the rows across several partitions. Okay. So, but again, each partition cannot have more than 2 billion records. So in case I have 4 hosts, and so in that case I can have in a single table 8 billion records. Now other advantages what you can get is like partition running. That means whenever the queries which are analyzed to determine that whether or not they match the given partition specification of a table, so based on this, the query will be optimized to execute with the partition data. Okay, if it is a much more partitioned data, so more threads will be assigned to the query, and the query will automatically get work on one partition set, and another part of the query can work on another partition set. So suppose if I have one table, let's take an example of 3 tables here, which is shown, and we have 3 servers. And each table has columns like year A, year B, year C, and so on. So when I distribute or partition the table across, like I want all the year A columns of all the tables to be accessed by the first host. So I can create a partition and assign that column A of all the tables to read that table. Second, I can create a partition with my year B in across all the table, and third, I can create a partition with year C of all the tables. So one example where I want to read all the year A data can be very easily read in the horizontal format. Can you see that first server can read all the year A data? Yes. So I do not have to maintain a table lock on all the tables, and except I can very easily read the data from 3 tables at the same time. This also gives me a vertical partitioning, faster read, where I want to read, let's assume year A from table 1, year B from table 2, and year C from table C. So in the same script, when we write same SQL script, select year A from table 1 union, select year B from table 2 and union, select C, table C, ERC from table 3, I can very easily do that, and I can also assign, the system will automatically assign multiple threads to perform this operation.
Okay, for one question here. So suppose in case table A or year A is having more than 2 billion records, how it will be partitioned?
So once the table A is there having more 2 billion records, so you can actually partition by using your row or range. That is called your range partition. You can specify, okay, in the first host, I'll have around 25 million records. In the second row, second host, again 25 million records, and so on. Now, since the first host is having 25 million records, I can again still add 75 million more, 175 million more records into that, because I can have a limit of 2 billion records in the table in a particular server. Okay, so in this way, I can add 175 million more records in each of the tables. So other advantages what you get is improved performance due to delta merge. So the performance of the delta merge operation depends on the main index. So if data is only modified in some specific partition, then the delta merge will happen only for that particular partition. Instead of working on complete data set, it can just work with a smaller data set in a particular server. Now the other concepts, which is the insert only on the delta. So SAP HANA was earlier told that, okay, the OLAP is good, it is fast, and we can have a good read on that. But what about the faster inserts? Like inserts coming from the ERP, inserts coming from the POC, and inserts coming from the sensor data. They're quite huge. So SAP says that we are not just SAP OLAP optimized, but we are also OLTP optimized. Okay, and the inserts can also be done at a very faster storage. How is done that? SAP HANA has two different types of storage. One is called as your main storage, another one is called as your delta storage. Okay, the read operations can happen on both main and delta, and the main storage is basically your columnar storage. Okay, and it is sorted data, it is indexed data, and it is the actual data on which we will read for the tables or queries. But the delta contains two different sets. One is called as delta 1 and delta 2. Okay, now delta 2 is basically a row store which will be accepting the inserts, and delta 1 is basically your columnar storage, and it is, but this columnar storage is not sorted, it is just unindexed data. Now what happens, deltas are basically your write optimized. Since it is not indexed, even the column store is write optimized, and read operation happens on both the main storage and the delta storage, but your write operation happens only on the delta storage. Okay, and update happens only by inserting. Now what happens when the data comes up? So when the data comes up, it will go to the first delta 2, which is your row store. Then all the write operation will go to the delta 1 store, and all the read operation will go to the main memory before the any insert happens. When any insert happens, all the write operations go to the delta 2 storage, and read operations are during that time the read operation happens only on the main memory and delta 1 and delta 2.
Sorry, delta we can call as a cache memory or sub memory?
No, it is not a cache memory. It is one separate memory area itself which is dedicated as a row store. That means whatever the data will come in that, it will get stored as a row store.
Okay, so basically what HANA is doing for the writing a data, they are going for row store as a delta memory, And for reading, and they are going for a main memory, which is column level.
And after some time, when the inserts are done, these two data stores will get merged. Okay, this is called as delta merge. Okay, now this delta merge is asynchronous, and then after this delta merge is done, the compression will happen. So what exactly happens in delta merge? Let's understand that part. Suppose all my write operations has been done in your delta 2, that is in your read store. Okay, what happens during the delta 2? Once all the data is written, this delta 2 data is converted to a delta 1 data. This the content of the delta 1 is now your columnar storage. So after the inserts are done, automatically within a asynchronous transfer, this delta 1 will get merged with the main memory. Okay, and all the committed entries in delta 1 are merged into the new main storage, which will become the main 2. Earlier it was main 1, after the merge it became main 2. Okay, once a merge is done, I will no longer read for that data onto the main 1, I'll just read the data on the main 2. So what happens after the merge is done? The main 1 data is deleted and the delta 1 data is deleted. And the main 2, which is the latest merge from your main and the delta 1 are sorry it is compressed again and it is further optimized. Okay, this is how the delta merge will happen. And so what will happen, what are the benefits you get over here? So benefits what you can get is that suppose you are reading the data at some time and at the same moment you are inserting the data. Okay, so that moment my read is happening only on your main storage, but insert can immediately go to the delta storage. That means it does not wait for the table lock to be released or the read lock to be released from the main store and then it will insert. So it can also insert at the same time while you are reading the data, and once you have read the data or once your inserts are complete, this delta merge will happen. So next time when you read the data on the same query, you are only reading the updated data.
Okay, so the delta merge will happen after the commit, the transaction commit statement, or
once a commit from delta 1 is done, so that time your delta 1 will merge with the main memory. Now there are different paradigms like other innovations, like earlier we have seen that data used to be brought from your hard disk to the main memory, and where the further calculations on data was done. So that approach was called as a classical approach, in which the data was brought to the code. So even in a lot of applications, we see that the application layer will bring a lot amount of data into the application layer, and it will perform all the aggregations, filters, and other operations. But SAP says that that is not a very good approach, and we cannot get a very faster result in case of a huge amount of data. Small amount of data, that is fine, it will not be posing much of an issue. But for a huge amount of data, suppose if you want to bring 2 TB or 10 GB of data, so you cannot possibly bring 10 GB of data into your application layer and work on that. So SAP says that rather than bringing data to the code, let's bring the code itself to the database. So what are the benefits what you get over here? Only the summarized data is sent from your database layer to the code or the application layer, and there is no huge movement of data, so even my speed is much more optimized. Furthermore, my application layer resources are freed. They are not involved in calculations of calculations of scan or filter or aggregations and so on. All these are handled by the DBMS itself. Go through these concepts of columnar storage, the delta and the about the concepts of data merge, about the concepts of partitioning, and so on. Okay, we'll see how the evolution happened for in-memory, and also some of the benefits for the in-memory as a data store, what happens with the new programming model, and so on.
Hey there, ready to dive into the world of SAP HANA 1.0 SP12? Our course is your ticket to mastering supply management. You can learn at your own pace, right here on our platform. In this course, we will unpack SAP HANA 1.0 SP12, the ultimate toolkit for planning everything, from ensuring we have got enough products to get them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors? They are pros with years of experience, dedicated to helping you learn and answering all your questions. And guess what? Our students love it. Just like you, they have found our course incredibly helpful. The best part? It's super affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA 1.0 SP12 Pro? Sign up on our page now. For more info, visit ZaranTech's website.
Completed some of the topics like the software optimization, then insert and data and partitioning, and columnar storage, and so on. So these are the hardware innovations which are available from SAP, and SAP HANA is built on based on these hardware innovations. Now, coming forward, now we'll see that what is the history of SAP HANA, and also what is the architecture, and also what are the various offerings of SAP HANA. So SAP HANA came in picture in 2010, but before that, many other different products which also came as part of the different releases of SAP's innovative solution based on the customer's requirement. So few of them were SAP APO, and that was something which was in 1990, and it was a huge amount of supply chain data which needs to be analyzed from the company and the partner process, and there was a need of a real-time information for planning, demand, supply management, and so on, and production planning and so on. So there were more than 2010 customers for this. Second came up, and that in 2004 was NetWeaver Enterprise Search. So this was basically your T-Rex, where we used to have a search for the data across different sources simultaneously, and it is very much like your portal search what you have in your organization, where you can search on different data components, the structured, unstructured, boiled, blog, and everywhere. Except that T-Rex can also search on the data elements also. It can search on the data store, it can search on your PDF, it can search on your unstructured data along with it can search on your table and so on. So it became a single entry point for your work, and this enabled the formation of T-Rex or the search capabilities which is used in HANA. Then in 2006, BWA came in picture. So BWA is your accelerator for business warehousing, and this in turn was to perform the query performance for BW, and it also allowed a lower TCO for BW, that is no aggregates were required now, no reduced complexities, less disk space was required, and also the data reduction was quite data latency was quite high. So data latency was quite less, and there are a lot of more benefits compared to this. And this was quite a recent one where this came in picture because BW was not able to perform based on the huge amount of data, and all the runtime calculations were not present over there. Okay, so apart from this, there are other differences between your HANA and BW, like some other things I would like to specify is HANA is a data mart scenario, and your BWA is basically built on your BW database, and your BWA becomes your the BWA is built on your is an application built on your BW, and that is called an BW on HANA or BW accelerator. So my BW accelerator was the foundation to bring to form BW on HANA architecture or the sidecar scenario.
Okay, so BW accelerator is a tool, right? Is a tool on
It's a separate tool itself.
So this accelerator is used mainly for
It is more. It was BWA accelerator was an in-memory tool, and it was mostly used to accelerate the BW queries by reducing the data acquisition time.
okay.
Now, and BWA was focused on improving the query performance of NetWeaver BW and can be used with any BW 7.0 onwards. So you can also create your BEX reports or reporting and analytical tool like business objects or even your dashboard using the accelerated queries with the BWA. So when I migrate from BW on HANA, the BWA becomes obsolete. That means your HANA gives you much better performance compared to a BWA. So these are the basic comparisons between the BWA and BW HANA.
So that BW is not using right now, is outdated, right?
No, it's not like an outdated. Lot many customers who are just using BW are using BWA accelerator. So what happens? Yes, BWA in a similar concept, BW on HANA models, the architecture for those things came up. Earlier, it was only meant for accelerator, only meant for your BW. But with HANA, the accelerator, HANA will act like an accelerator for all the database elements. So that is the one example, and so that it is not mandatory to have a BW. You can use any data to enhance its processing capabilities using HANA. So with 2010, SAP HANA came in picture, and SAP HANA enabled the users to analyze a large information in real time at a very high speed. Okay, and this was mostly meant at the beginning of only structured data. But now we also have structured and unstructured data, and still we get a huge speed to work on this huge data. Second, SAP HANA allowed us to create your analytic-based applications called your HANA models, which will be the base for your analytics part of the SAP HANA. Third, the HANA DB not just acted like a database and your analytic appliance, but it also acted like a platform. That means it can host the applications for web-based applications and also deploy the applications. So you can create new type of applications like planning, simulations, and various other sentiment analytics and so on using HANA. So 2010 onwards, there are a lot of good benefits for HANA, and HANA came in picture after seeing a lot of the advancements in your T-Rex, BWA, and your live cache scenarios. Okay, so let's go to the now main part, that why RAM is being used over there. RAM is the main storage of the database of the system, and is also actually the second highest storage into the data. And also the RAM, since the cost of the RAM is decreasing day by day, so the RAM can house huge amount of data, okay, which can be used to contain the HANA based data. Now the CPU registers and CPU cache are still faster than RAM, but they cannot be expanded to the size of RAM, and also it does not. There are other factors which will not be available for the execution. So hence, RAM is the most suitable main memory which can be used for a faster data processing. And data in the main memory can be accessed almost more than 1,000 times compared to the data access in the secondary storage. So this is a new model where you have earlier we used to have the disk based. Okay, so earlier we used to have this architecture where it uses in-memory cache conscious data structure. Okay, what happens in this case? Like there is a huge amount of data which is flowing from your disk or the secondary storage to the main memory, and from main memory to the CPU cores, and in turn to the CPU cache. So the bottleneck lies at two places where the data is being moved from your disk to the main memory, and there's a huge input output read is required, and also there's a bottleneck at the movement of data from main memory to the CPU cache, so that is not so fast enough to implement the data, and hence the CPU keeps on waiting for the calculation. So this is just a speed comparison with SAP HANA and actually HANA with R3. So if you see that earlier we used to have database, then we have calculation, then we have presentation, then we have the platform, that is Unix, Windows and Linux, and the data used to take around 50 to 20 milliseconds from in the beginning, then from database to calculation it used to take 1 millisecond, and finally to the presentation there. But in this case, the SAP HANA is on the platform SUSE Linux, and they just have two layers, that is the presentation layer, that is addition layer you can create on top of HANA. Then you have your calculation layer, which is present into your in-memory data store, in-memory data engine, and the third is your persistency, that is how the data is stored in the database. Now if you see, the whole data is into the RAM itself, so and the RAM will perform all the calculations, all the requirements. So we can just say that there is no movement of the data from your database to the main memory. Instead, the data is at the RAM itself, and hence the input-output read is totally totally not to be used over here. Okay. So now, what is SAP HANA platform? Earlier, SAP HANA used to be known as your SAP appliance, but now SAP HANA is called as a platform. The reason for this is very simple. There are different type of solutions available, and there are different types of the database feature which enable your SAP HANA to accelerate your business process, deliver the much more business intelligence, and simplify the business IT environment by simply providing one single solution. So it helps me to reduce the complexity, and also I can run the application anywhere along with the real-time results. So what are the key capabilities of your SAP HANA platform? So there are 4 different areas, that is your database management, then you have application development, then you have advanced analytical processing, then you have data integration and quality. So some of the things which you have already discussed are part of your database management, where you will see that the columnar storage is one of the primary component of database management, then advanced compression, multi-tenancy, multi-tiering, okay, and your data modeling, openness, administration, and security, and high availability and disaster tolerance. So there are other things which you have not heard, so this is the first time you would be hearing. So let's quickly take that. Multi-core and parallelization, you would have known that SAP HANA is can be used as a distributed system, and hence the data can be structured across different partitions of the system. So you can assign the data to be different servers, and hence the different servers or the distributed server can work on this data separately. Apart from this, there is a multi-tenancy. Multi-tenancy means that having a database inside a database. So as if you remember earlier, we would have seen the use case of SAP HANA where there's a problem with the current landscape. There are different silo data, but SAP tries to solve this as a platform and says that all the data will be present into the one single HANA system. But still, this departments want to have a separate data inside the main master data. They can go for something, the concept called as multi-tenant database. So SAP HANA is a multi-tenant database, and I can create the tenant database inside the SAP HANA system. And these databases are quite independent of each other, and there will be separate system. The tenant databases can be stopped, they can be recovered, they can perform any operation which is required, and it will act like a separate entity at all. So apart from this, you have multi-tiering. Multi-tiering means a multi-temperature memory strategy. So what does a multi-tiering mean is the data can be kept in different servers based on the data aging. For example, the very hot data will be in your HANA and can be loaded into the RAM, and the cold data will be in your Sybase IQ, and which can be retrieved whenever it is called. So based on the concepts of the data aging, the data will be distributed across different types of server like your HANA server and Sybase server and so on. Okay, so there are different types of data, is also like hot data, cold and warm data. Okay, so and also there are different types of data usage profile. So based on this multi-temperature memory strategy, the data is split across different types of databases based on the cost and the licenses and the support. And so SP dynamic tiering enables the users or the admins to optimize the main memory resource in SAP HANA by using the extended table for VW objects with warm data. So one of the concepts which is used for dynamic tiering is the extended tables. And extended tables can be very easily directly created on top of HANA.
So I have one question. So application development, advanced analytical processing, data integration, quality database, these are all the so HANA as a platform, we can do this kind of activities. So we can also use SAP HANA as a database, or we can do as an application. So right in that, so you are showing what are the tools. For example, application development, you are showing web server. These are all the activities we can perform, right? On that.
Correct. That HANA database will act like a web server. Then HANA database, you can write your JavaScript directly into your HANA database. So this is what I'm trying to tell you.
Okay.
Okay. So these are the database concepts like your columnar storage, multi-core, advanced compression, then data modeling. These are all the basic database management components, and these are the features which are available in HANA database. Okay, like your admin and security is the general admin and security of the HANA DB. Then your high availability is and disaster tolerance is very much required in today's world where my data is volatile and the data will go up. So I should have a high availability planned for the database. Apart from this, the data modeling concepts of the creation of the views comes up into the data management part of the DB. Apart from this, there are other areas like your application development, like where the HANA database can work like your web server and host your applications. The HANA database can directly process on your JavaScript, okay, because it has inbuilt XSJS JavaScript handler. Then your Fiori, SAP Fiori user experience, that is your UX, can be designed on HANA. Then there is something called as graphic modeler or the flow graph modeler, and there is also a concept called as the KPI generator or the KPI modeler. Then there is application lifecycle management. You can actually maintain your applications lifecycle, share it with your team, work with different data. You can debug the data. You can do many more operations what you can do directly on the code. So this is from the web development side. Another things are like advanced analytics processing, like SAP HANA is a spatial database. So spatial database means your those databases which can process on the latitude, longitude, and the vector space. So SAP HANA says that okay, you can keep a point, you can name it as a one vector, and you can find out the distance between two vectors and whether the first vector crosses or intersects or other operations can be performed on these two vectors. So there are many more things like if polygon can be created like similar to your Google map, okay, and a different relationship between the different predicates can be used. So SAP HANA is also a graph database. So graph database is basically the database in which the graph structured are used, which are basically for your semantic queries and node edge representation of the data. Okay. This relationship between the nodes and the edges of the data allows the data in the store to be linked together directly and in many cases retrieved with single operation. So one of the example is like in your banking, there is one customer ID, and with this customer ID you can see your transactional detail, your total loan account, or any then what is the interest rate you are getting, what is the saving accounts you have, what is the current accounts you have, and what are the loans, what is the current loan accounts you have or credit cards you have, and every other information you can see from using your main customer ID. So similarly, the graph database can provide a relationship between all these entities and see that whether a person is doing any fraud or if the person is using any fraudulent method to get some benefit from the bank. Other features are like predictive. SAP HANA is a predictive database and it can work on the PAL algorithm and AFL algorithms which are imported as a separately and not part of SAP HANA basic license. Your fourth is your SAP HANA search. So SAP HANA search is basically your T-Rex capabilities where your the SAP HANA's built-in search feature can be implied for text mining and text retrieval and search. So some of the features which can do is like Google-like experience, like it can do a vanilla keyboard search, it can do linguistic search, it can do a fault-tolerant search, it can do fuzzy search, it can do semantic search, and so on. Okay, so we'll see a search capabilities later on, and we'll see a demo application where we can see how the search exactly works. Then we have something called as a text analytics. So text analytics is something which I was talking about where you cannot just do a fuzzy search or the enterprise search, but you can also say that you can perform advanced operations on text data. So you can say that you can extract meaningful information from your social data, your news, blogs, and you can work with that. So that is an enhancement on top of your search where many operations on the text of on your social data can be done. It can read on structured or unstructured data, and you can combine this unstructured and structured data to get more meaningful insights from your social analytics or from your structured data. So apart from this, you have streaming analytics, series data, and business functions. So streaming is basically your any reading of the data from any of the streaming devices. One of the example is your IoT devices and work with the streaming data at real time. Your series data is basically your time series data, on which the data SAP HANA can work. And this came in from SP12, where the time series data can be used for creation of your advanced functionalities on time series or your ordered sequence of data points. So you can analyze and predict based on like forecasting, signal planning, and also extract any statistical information out of this series data. Okay, so these are based on using SQL functions. Okay, like creation or generation of a series, series disaggregate, series generate, series rounding, series period, and a series element to period, and so on. And only through SQL it can be processed. Last is your BFLs. BFLs is basically your business function libraries, which will provide you the business related functions in your SAP HANA, like calculation of a forecast, calculation of maximum minimum, calculation of year to date, date to year calculations, and so on. So those business related requirements are calculated using BFLs. Apart from that advanced analytical processing and application development, it also has data integration quality. So few things like you can do the data virtualization, that is you can bring the data from other non-SAP sources like MS SQL, IBM DB2, DB4, DB6, Oracle, and so on, using the concepts of SAP HANA data virtualization or using a remote source. So the data which is actually brought in HANA is only at the runtime, and no physical aggregate of the data is made. Only a connection is to be maintained between the source system and the target system, and the data retrieval will happen over there. Apart from this, you can perform ETL using your DXC and your other database, and you can also do smarter data profiling and data quality in SAP HANA using smart data integration and smart data quality. It also has a integration with Hadoop.
SLT is coming where SLT is.
SLT is a part of data provisioning, replication.
Okay.
Your ETL part, ETL and replication. SLT will come over there.
Oh, okay.
So Hadoop integration and Apache Spark integration is feasible now, and you have a remote data sync. That is, this feature came in from SPS10, and this is a new feature which so it is basically part of your remote data sync, or also called as the RD sync, where it allows the synchronization of the data between your SAP HANA and the remote devices. So let's take an example like sometime the device will be connected to HANA, but sometime the device is not connected to SAP HANA, and in that time the remote sync will come in picture, where whenever the SAP HANA and the device will get connected, immediately the data will do a synchronization of the data between your application and the SAP HANA database. So this is quite useful for places where we know that there are frequent disconnection of the connectivity between the SAP HANA and the whole platform.
Hey there, ready to dive into the world of SAP HANA 1.0 SP12? Our course is your ticket to mastering supply management. You can learn at your own pace, right here on our platform. In this course, we will unpack SAP HANA 1.0 SP12, the ultimate toolkit for planning everything, from ensuring we have got enough products to get them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors? They are pros with years of experience, dedicated to helping you learn and answering all your questions. And guess what? Our students love it. Just like you, they have found our course incredibly helpful. The best part? It's super affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA 1.0 SP12 Pro? Sign up on our page now. For more info, visit ZaranTech's website.
Or to your devices. Okay. So these are the various advancements, these are the various components of SAP HANA and so on. So I would ask you that to go and read through SAP HANA platform and how it can be used in different scenarios.
Okay, so that Apache Hadoop integration you are saying, right? How SAP can it will be normally database we are installing some drivers, right? Normally,
Yes, it will be using the HANA Spark ODBC driver.
Oh, okay.
Then using the Spark ODBC driver, we could create a remote data source and bring the data from Oracle or sorry, from the Hadoop.
Okay.
Okay, so let's go to the next set of slide. So these are the certain benefits of using SAP HANA as a platform. So some of the companies like Joskin, they provided when they had a SAP HANA, BW HANA and SAP HANA Live, then they could see a drastic performance of 171 times the data. Okay. Then Vodafone saw a reduction in data extraction ETL when in their SAP BW powered by HANA scenario. Okay. Then some of the companies they saw the reduction in total IT cost of ownership for Suite on HANA, Enterprise HANA Cloud, and some companies they explicitly used some applications which are built on HANA like sales and operational intelligence and so on, and they could see that it provides a very unified landscape now compared to earlier, and a complete picture of sales, profit, target sharings, everything were listed by one single application. NFL, like fantasy football platform, they use SAP HANA Cloud Platform and SAP Lumira to find out the growth percentage. And earlier we should take many more days for Florida Castles to migrate to SAP Business Suite. But with SAP Business Suite on HANA, this could be achieved only in just 3 days. Kraft Food were able to see the reports in many hours, but with SAP HANA and Lumira, they could manage to see the 3 million records in just few seconds. Sorry, the 50 million records in just few seconds. Apart from this, it also provided the faster reporting speed and also advanced tools like your BPC on HANA. So there are many customer stories on SAP HANA directly or SAP HANA Enterprise, SAP HANA tools and so on. So that's the reason I will suggest you that once you go for the basics of SAP HANA, go for the next layer or go for the next training for S4 or for your application development or your advanced analytics and so on. Okay, so how does the data get reduced with BW HANA part? The earlier actual data was running was 593 GB. Okay, and when it came into HANA and compressed, it became almost 5 times lesser. So we had 118 GB of data. Then further, when it was optimized and indexed, it was again reduced by 3 times. So the data became 42.4 GB. And with the concepts of dynamic clearing of hot data, cold data, and warm data, the actual data which is in the RAM was quite less, and almost 8.4 GB out of 593 GB the data is occupied. So the red ones on the screen which is being shown is your hot data, and all of this data needs to be present in the RAM or it has to be loaded immediately. Second is your blue zone, which is basically your historical data or the cold data, and some companies might have cold data in their records, and this cold data can be retrieved into different tools based on your requirement, and how the data can be positioned in different types of servers like HANA server or IQ server or so on based on the data aging concepts. So inbuilt data management capacity of SAP HANA. So as I told that the SAP HANA can provide the data management capabilities, and it can also use the hot data and the warm data concepts of and bring only the warm data in HANA. It can also work with the SAP Hadoop to work on the big data using the ODBC for Hadoop and Spark, and we can combine the data from the source data and the target data, that is your from Hadoop, and even bring up some calculation models on top of it. We can also store the unstructured data or any unused data as into the archiving format. Now, what is the earlier traditional approach? Earlier traditional approach was to move the data to the application layer. So the data used to be read from your core tables, and the data can be moved from your to the application layer, where it will go and get indexed, then create an aggregate out of that index, then again work on the multiple aggregates and indexes, and then do a aggregation, final aggregation, and then filters and many more operations were done beginning. And all these applications were getting, all these calculations were getting done at your cloud, at your application layer. And there was in fact a huge movement of data from your secondary storage to the RAM, and in turn to the application layer. So what is today's approach? What SAP HANA works out and tries to solve the real-time challenges of the world? It says that completely remove the application layer, and instead of bringing the database to the application layer, let's bring the application layer itself to the DB, and so that the database will be faster to read and faster for reporting. My database will be still able to host all the applications and everything, but except that some syntax will change, and there is no movement of the data from your DB layer to the application layer. Now there are different types of configurations for SAP HANA.
The earlier case, right, the application layer and the database will be connected through the network. So the network latency will not be there. So DB and application will be embedded into one single bundle.
Correct.
Right? So
there used to be separate stack for the application layer. You used to have your as a server, then you used to have a database, then you used to have different components. But with SAP HANA, there is no separate stack. The same HANA component can be used for doing the data provisioning. The same database can be used for data modeling. Same database can be used for your predictive advanced operations, and same database can be used for hosting the applications. Same database can be used for the older database. So we need not move the huge amount of data on the input or waste CPU resources on the input-output reads.
right.
Okay. Now, what are the different types of deployment scenarios which are available in SAP HANA? The first one is basically when you are using all-in-one box solution. Okay, and there'll be different types of blades in that system. You'll have 1 blade, 2 blade, 3 blade. Each blade can be multi-core, like 10 core, 8 CPUs, and like this, there'll be quite a good scale up where this SAP HANA systems, which act like your one single entity, can be combined with multiple entities, and hence you can have around 48 GB to 20 terabytes of configuration. But let me remind you, this is just on premise. So we can have 48 gigs to 20 TB of data can be adjusted, and there'll be like node 1, node 2, different nodes, and all of this will have its own separate software server, network storage, and so on. So what is TDI, or the Tailored Data Center. So TDI is a program that allows SAP HANA customers to leverage their existing hardware and the infrastructure components for their SAP HANA environment. So typically your SAP HANA appliance will contain all the necessary components, but even to engage the existing components of the like some of the customers will have Oracle DB, some of the customers will have MS SQL and so on. So different components like one instance is HANA, another instance is Oracle, another instance is MS SQL. So different instances of the database of the requirements will be present in SAP HANA and this will be formed as your TDI or the tailored data center.
Okay, so then while installing in SAP HANA, right, there are two types, right? HANA can be implemented as an appliance or TDI. TDI methodology will be for those having an various tools like database like MS SQL, Teradata, Oracle. So the customized TDI is more complicated, right, when compared to appliance.
Correct.
The customized configuration, TDI.
Yes, so to just use the customer's existing landscape and integrate SAP HANA with the existing landscape, the TDI concept is used. So there are other benefits also like other database might not be fast, but SAP HANA is faster for reporting. So connecting with them will bring the data into SAP HANA and then work. So what is this is basically it enables the users to use the existing landscape, and hence they not go through their landscape removal or the license restrictions and so on. They can directly use the existing license, existing hardware, and also enhance that with the SAP HANA. So that is something called as your TDI. In the below you can see that what are the various hardware partners SAP HANA works with, like your standard hardware partners of Intel, IBM, NEC, Cisco, Dell, Fujitsu, Hitachi, HP, and so on. It has also partnered with Huawei, Lenovo, Unisys, SGI, VC, EMC Square, then Fusion, HD, NetApp, and so on, just to increase the database compatibility and also to increase the hardware compatibility of these tools.
Okay.
Okay. Now, what are the other flexible deployment options we have with SAP HANA? With SAP HANA, we have the concepts of on-premise, on-cloud, or a hybrid scenario. So what is an on-premise solution? That means in on-premise, it is the complete SAP solution which is running on HANA is installed on a local Linux server, and this is present for your all the hardware, and the DBA guy will have to manage the system. The user security and all has to be managed by the DBA person. So this is a very generic scenario where we use in a remote desktop and connect to SAP HANA system. So that is something which is called as your on-premise system. Now, third is your cloud. So what is a cloud? Where we can build or run or deploy all the applications into your SAP HANA Cloud. So SAP HANA Cloud, I'll just take a brief of that later on in the slide, but it is just to understand that the applications can be built on cloud, and we can also do faster innovations. We can do simplified landscape. Customer need not do any installation. The cloud is managed by SAP, and we can directly start from scratch and start building the applications on HANA. Now there's a third category where we have hybrid scenario, where the data from your SAP HANA and data from your cloud can interact. So some of the cloud-based solutions are your Hybrids, SuccessFactors, and so on. And this data can combine together with SAP HANA data, and they can work in tandem with each other. So we can migrate some of the solutions to SAP, and even knowingly or unknowingly, we are following this approach, like when we are planning to work with the cloud. So we can create and deploy new software as a service option in cloud, and you can get the features of remote desktop, data sync, a cloud, uh, then cloud hosting and platform as a service, infrastructure as a service, and so on. Now these are the various other tools which are also available, and SAP HANA is central to complete SAP strategy in today's world. So going forward, when SAP HANA came picture in 2010, earlier it was only BW, then slowly CRM came in picture, then your parallel 2014 saw the advent of ERP on HANA with simple finance and simple logistics. In 2014 you have the complete S4 HANA where the ERP starting with finance logistics are on HANA. Then you have data warehousing concepts that is on BW HANA. Then you have operational reporting and BW, which is your HANA Live and BI on Lumira. Then advanced analytics like SNOP, COPA, BBC, and advanced features can be used with SAP HANA. Cloud solutions like your all the three different types can be executed. Then you have your success factors, sales and service management. So these cloud solutions can be easily invoked by the customers. Then you have a business network through Ariba. You have big data through Hadoop, and you have IoT through SAP Internet of Things in SAP. Apart from this SAP HANA platform, so every product from SAP either runs on SAP HANA or in future will run on SAP HANA. So that's the reason SAP HANA's learning becomes very prominent and very much useful for the consultants who are going to learn into different field. Now SAP HANA Cloud is also available in different third-party tools like your Amazon AWS, Microsoft AWS, and so on. And SAP HANA enables managed cloud as a service, that is your HEC, HANA Enterprise Cloud as a Service, and second as your SAP Platform as a Service, SCP. So there are many more disadvantages of using Platform as a Service, where you can just get limited functionality compared to your managed cloud as a service, where you get much more advanced functionalities, and the HANA Enterprise Cloud is managed only by SAP over here.
So the platform as service, right, it is having a limitation. We can use the services because the configuration will be already done by, already it is there, but we can't do any customization, right? Platform as service.
Sorry, we are asking for which component?
So that
platform as a service in HANA Cloud Platform?
Yeah. Platform as a service have some limitations, correct? We can't do any customization.
Correct. I'm just giving the platform to be used by the user, but I'm not going to give all into the sick details. Neither I'm going to give the data and the model. I'm just saying that you bring your own code, then you can bring the customization of that data. Okay. Now, what are the other scenarios which you have is your SAP HANA Enterprise Suite, that is your completely your ERP, business win, business by ID, success factor, and so on. Everything will be on HANA. Second is your using HANA as a database. So the concepts of storing the data, partitioning, DBA, and general purpose database or BI on demand can be implemented by this area. Third area is your SAP data warehousing. So SAP data is fastly becoming your in-house data warehousing concepts. So, and apart from that, we also have BW on HANA, and so with this, the business warehousing capacities of the modeling and the faster reporting can be utilized in SAP HANA. Then it also has OEM support, so original equipment manufacturer support, that is bringing the metadata, MKT, Tulia, and other third-party data into IBM and work on those data. Then you also have your disk-based application accelerator, like using COPA accelerator, using customer segmentation, using ERP, operational reporting, and so on, with the disk database and the applications. Also, you can create your advanced applications on HANA database. That is your smart meter analytics, last classes of SNOP and so on. Okay, so you can build up your advanced or new applications on top of SAP HANA, and not just use HANA as a database or analytic appliance, but also as a central for complete ERP suite on HANA. Okay. So by this we will wind up for today's session. So for tomorrow's session we'll have 1 hour. Then we'll be able to complete this topic by tomorrow. So there are a few more topics of cloud options, what is the cloud, and other scenarios and then the options.
Okay.
Any questions, any doubts till now?
Now we are covering only the basics of HANA, right? So
correct. So once this is done, once we are done with unit 1, that is all the concepts of HANA, then we'll start seeing in action that how to do the actual modeling. So this why these concepts and topics are told to you is because they almost carry around 4 to 5 marks in the certification.
All right, let's test your knowledge. Here's a question for you. In SAP HANA 1.0 SP12, which database engine was introduced for storing and managing large volumes of cold data? Option A, row store. Option B, column store. Option C, extended store. Option D, disk store. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, ready to dive into the world of SAP HANA 1.0 SP12? Our course is your ticket to mastering supply management. You can learn at your own pace, right here on our platform. In this course, we will unpack SAP HANA 1.0 SP12, the ultimate toolkit for planning everything, from ensuring we have got enough products to get them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors? They are pros with years of experience, dedicated to helping you learn and answering all your questions. And guess what? Our students love it. Just like you, they have found our course incredibly helpful. The best part? It's super affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA 1.0 SP12 Pro? Sign up on our page now. For more info, visit ZaranTech's website.
When do we use a BODS? We use a BODS when the data is stored into different types of databases in your organization, and you are asked to bring the data from different sources into a HANA system or through one system, then you use BODS. Okay. Now, another major benefit of using a BODS is that when you want to do a huge number of transformations, that time you'll use the BODS. Okay. So let's see that what are the advantages. So BODS is basically an ETL tool, that is an extract, transform, and load, which can help extraction of data from any source, example Oracle, IBM, MS SQL, or any other database, into its own server, then transform the data or do any modifications, data profiling, data changing, data cleansing, or data filling, and then push this data from your data services to your HANA system after the modification. Okay. So BODS is one very comprehensive tool which has been present in the market for quite some time, and it is one of the well-known tools for ETL in the market, not just for bringing data into HANA, but also for an ETL capabilities. Okay. So how does an architecture look like? So a very simplified architecture is you have a SAP Data Services Designer, where the designer connects to the different sources. The source can be a data source or it can be a application source, and it also connects to the target, like in this case it is an SAP HANA, or it can be any other target. So I was talking about architecture where the multiple sources or even heterogeneous type of sources can be used to bring data, metadata from their system, and it can be moved to any kind of target. But in this case, we'll be moving the target into HANA system. Then between the movement of the target, we can do a lot of complex transformation, merging the data, then data profiling, data tuning, data fine-tuning, conversions, and so on. Many things are possible. Some of the things like fix invalid values, check values are within the valid range or not, add any missing fields, cross-check the data sources, combine the sources, merging or union, then adjusting the formatting of the field, currency conversions, and so on. So SAP Data Services is a separate tool and it is not part of SAP HANA offering. So there has to be a separate license for this tool, and this can also be used with other databases, not just with SAP HANA database. Okay. Now, SAP Data Services is a one-stop solution because it combines 5 different types of tools of information management into one tool. Okay, so SAP Data Services is the one and the only one tool which has data integration, data quality, information stewardship, that is your data profiling and metadata management, as well as the text analytics. So these are the different tools which come as part of the data services portfolio and can be used extensively for all the different kinds of work. Okay. So in this session, we'll be working on the data movement only and not at the other areas. Okay, so we'll be working mostly with the PO designer. So what are the different types of flows which can happen for moving the data into and out of SAP's application? So let's assume that you have SAP Data Services and there is a job running. Now this job can connect to an SAP database through an ABAP flow, where it can create an ABAP transport request, ABAP data transport request, and it can read this data transport request to do a faster processing of the data. Second method is either it can connect to a database and trigger PAPI calls and read the data. Third is it can connect directly to iDocs and work with iDocs to bring the data into HANA. It can load and read the data. The last step is when the data has to go through a proxy server for the conversion or any other such kind of work. Then we can go for the access server replication. Okay, so these are the things which have been explained, like data exchange via RFC. So it reads the data from your SAP application using regular data flow and supports tables only for small data sets only, and extractors. When we are going for an ABAP flow, when we connect to an backend SAP system through an ABAP flow, so we support flows, tables, hierarchies, extractors, and functions with a scalar argument, and many more. Okay. Then if we are using a RFC call or PAPI call, then we load the SAP applications and allow the direct access of the application table outside the data flows and through RFC calls. iDocs, so the SAP Data Services can create, can read, can send, and can alter the iDocs, and Also supports reduce input risk, input set, parallel processing, real-time processing, and batch processing for this. So this is the basic flows which are there and how based on each situation they can be used. Now what are the steps to connect to an ECC system, or now ECC is not working, so we'll be using a BW system itself. So first step is to open your designer. In the designer, log into your area of the workspace. Okay, once you have logged in, then create a op source and import the metadata from that source to the source. Okay. Then bring the data of the source into the server. Meantime, we can also add the target which we want, and we create a data services job to match the source and the target. Okay, so let's see that how we can connect it to a BW system and how we can use the data services in creation of a data flow. Okay. The first step is you're connecting to a backend system. In connecting to a backend system, you have to specify what kind of database, what kind of application it is, or how we can connect to a backend data source. Okay. During the application, in case of an SAP org or SAP, sorry, during a connection, so we have to specify what kind of database it is. So it is an SAP application database, or it is just normal SAP application. It is Oracle, it is IBM, it is MS SQL, and so on. So we have to specify which type of database is there, and based on that, we have to specify what is the source, what is the target, and how you want to push the data. So this logic of complications, transformations, and everything will be given by the transformation or the query transform, which in turn will contain a lot of different functionalities as the movement of data, then changing the data, and many more. Okay, so to enable one-to-one transfer, the source of the system has to connect to a target system, and it has to be connected through a query transform, which in turn has the screen and the for performing the operations or the performing the functions of BOTS. Once you have executed, so you can see that data over here in your table. Okay, you can also see, go back to your HANA system, see the data. Okay, now let's see what are the steps which needs to be done. For that, first I need to go to my, so I'll go to my data services. So if I see what are the packages which are installed, so as part of this, you have a database, data services local leak selector, data services management console, data service repository manager, data services server manager, data services workbench, and data services license vendor, and many more. Okay. So we'll use data services designer. So here we should make sure that our system is BO server, then :6400, and give the credentials for login, and make sure the authentication is SAP. Once you log in, so you'll see that you are presented with a different type of repository. So repositories are same as like we have in HANA. So these are basically the local workspaces. But in this case, the workspaces are not in local, but they are in server side. So what kind of workspace we need to use will be given in your HANA details text file. So we have to use the repository as HANA user. Okay. It will ask for the password. Give the password. Now once we have this, now this is my designer. In the top you'll have the menu bar. In the left area you'll have your project area, and in the bottom you will have the various other tools or the local object library. In the middle you will have some shortcut links and any recently opened project or any community forum blueprints and so on. Okay. So this is my ribbon bar, which will be used for a lot of functionality, and there'll be a ribbon bar which will be on the right hand side. So for the first thing, let's see the objects of the project area. So this is a project area. Here second tab is a monitoring tab, third tab is a log tab. So designer is the main tab where you'll be working. Okay. Then you have in your bottom as the different tabs like package tabs, and we have connection type of jobs, workflow tabs, data flow tabs, then transformation tab, then data store, then formats. Okay, so you have a lot of nested schemas you can write. You have a Hadoop file system, then you have flat files, then you have Excel workbooks. Then we can work with the different file locations, and also we have different custom functions for particular databases, and you can also get the international functions. Okay, so these are the functions where you have transformation, you have text data processing, you have a case statement check, then you have a row in the SQL generation, validation, SQL map, data quality like putting up the data quality, data flattening, hierarchy flattening, and so on is done over here. Okay. Now let's start getting to work for creation of a project. Okay. So before we go ahead for creation of a project, I need to add the data sources. Okay. So for this, we need to go to this icon which has tab which has data sources as a limit. So right click on anywhere in the data store page, then click on new, and we can say BW, or I can just say earlier I was supposed to do with usually I do with ECC, but since ECC is not working, so I'll try and check with the BW system. So what is a data store type? So it can be a database, it can be a JD World, it can be an Oracle application, it can be PeopleSoft, it can be an SAP application, it can be BW source or REST, full REST API, or the SOAP architecture is there. So based on your requirements, you can change the type over here. So in this case, we have BW source, and then we need to specify what is the BW type. So you can always go there and say application server name is BO server, username is HANA user. Then you need to go to advanced, and in advanced we have to give the client number. So client number is 800 is correct. Then we have to give the system number. System number is basically your SID. So these are two things which you need to mention over here. Other things also you can change it, like whether you want more number of intervals between the retries, or how many data should come at a one time, what is the default package, what is the default the class. Okay, so let's click on apply. Okay, once apply, busy cursor is gone, that means it has been able to log in. Now click on OK. Once you click on OK, so you'll get to see the your source has come up. Now, since it is a BW system, you can see functions, IDOCs, OSD, OpenHub testing tables, then tables, normal tables, and so on. In case of a ECC system or the ERP system, you would see functions, hierarchies, IDOCs, ODP, and the tables, which are used for the transportation of the data. Let's first bring some data from the table. Okay, so we do not have a transaction tables from ECC in this system. So we have a header table and so, or we can see if we can. I think the master tables are there. Okay. People also. I'm not very sure whether this will work properly, but let's try and see that. Okay. So we have SMWD VPN. So we'll go to the designer and first import the data into the data services repository. Okay, so right click on this and choose import by name, and it is of type data type table. Just give the table name, click on import. So once it is imported, you can see it is existed and you can always see the data. It is not able to display the data because of the binary format. Okay, not an issue. So we'll try and work with the S item.
maybe like a vendor table or a customer table. Maybe we can try.
No, the table is not even there. Can you doesn't exist? None of the transaction tables will be available.
Wow.
Mm,
What about the CE1, CE2 data?
those are this will not also be available because that time I have brought it from the ECC directly. So BW replication has not been done. So we have got some table, so very random table, and not a transactional table at all. So we'll just try to bring this into a HANA system. So for that, I have created my source. Okay, so next step is to create a target. In this case, it is a HANA system. Then right click, then again new. In this case, I'll say train underscore HANA, and it is of type database. Then what is the type of database I can use? I can use different types of databases, but in this case I'll use SAP HANA. Then what is the database version 1.x? Then I need to choose the direct option to connect to HANA database, or I can choose it from an ODBC or through a DSN. So from a DSN I can get HANA server. So username is HANA user and password is this. Okay. Make sure this enable automatic data transfer is checked. Okay. Now click on apply and click on OK. To test this, so let's just try and import some table which we know is already present. We know that C1 idea table is already present in training schema, and if you are able to import it, then it should be working fine. Looks like there's a huge amount of data, but it has got the data. So my connection to the HANA system is working fine. Now what are the steps to do that? First step is to create a project. you click on this project. So let's say BW2 HANA. Okay. Now in that I'll create a batch job. In the batch job, I'll say the same thing. Then once the batch job is open, this is a batch job where I can use it. On the right hand side, you will see there are certain more tools like data flow, workflow, then your scripts or conditional statement, and so can be written. So it can be many which ways, like if you have one condition, it should do this, or it should have, if it has another condition, it should do that. So we just need to bring the object from the right side panel and work it. So suppose in this case, we wanted some catch of the exception. So catch statement can be written. So let's just try out a simple scenario of bringing the data. So I'll put a data store, and in that data flow, I'll keep your table name. RSD area T. So in this case, I'm going to define a flow which brings the data from this source. I'll drag and drop the source over here. Okay. And I want to put this data into HANA. So for that, I'll put a transformation or the query transform. With be like that, and I want to put this data into HANA through either I can create a table already existing and map it in the through the HANA system, or we can create something like a temporary table, just like how Excel automatically creates the columns. So a template table will automatically create the data type and the column, and once it is mapped in 1:1 format, then the data can be extracted. Okay, so in this case, I'll also give in which data store we want underscore train HANA, and what is the schema? Owner name is a schema name which we want to move the data. So we'll say training. Okay. Now click on OK. Now the source, the transformation, and the query are defined. Now we need to connect it. And the method to connect is right click, connect to, it will show you the list of the unoccupied objects. Okay. Now my source is ready, my template table is also ready. Next step would be to do a mapping between the sources. So once you double click on the query transform, you will see a two side of the table. One is the schema in, that is the input schema. What is the schema out? That is the output of the query transform. So in this case, you can select all the objects of the RST area T and map it to the output. Now the output of this query transform is same as the input of the query transform. Then you can write certain select statement or distinct count or repeat statement or so. So where clause or any functions or group by or order by, anything whatever you want, you can write it over here. Now once this is done, so you can do a lot of other options as well. So I need to go back and say that this flow graph is complete. So I will quickly save Once this is done, I need to run the batch. So I'll right click on the batch job and click on execute. During the execution, it will ask me what kind of server to execute this batch. Okay, and we can use a job server as SAP HANA user at the BO server :3501. Let the other details be in the default parameter.
Hey there, ready to dive into the world of SAP HANA 1.0 SP12? Our course is your ticket to mastering supply management. You can learn at your own pace, right here on our platform. In this course, we will unpack SAP HANA 1.0 SP12, the ultimate toolkit for planning everything, from ensuring we have got enough products to get them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors? They are pros with years of experience, dedicated to helping you learn and answering all your questions. And guess what? Our students love it. Just like you, they have found our course incredibly helpful. The best part? It's super affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA 1.0 SP12 Pro? Sign up on our page now. For more info, visit ZaranTech's website.
One topic is DXE. So DXE is basically a out-of-box replication tool which is based on your SAP HANA Business Suite entities. And the DXE concept of DXE is very simple. Why do we use DXE? It's a lower total cost of ownership. Okay, no separate installation, and also we get a faster replication from the source system to target system. Now, how does DXE is used? Even though there is no installations and so on. So DXE uses the concept of the embedded BW, or the BW which is present on every NetWeaver system since NetWeaver 7.0 installation. Okay, so the BW what you have is something which you have in production environment can be on apart from the your commercial BW license, and that BW what is called as embedded BW. Now this embedded BW is not utilized at all, and customers usually go for the customized BW if they want to work with the BW segments. Now, so with DXE, the idea is to use this embedded BW and transform the data and the transport data from the source system to the target system. Okay. Now, what are the advantages of using a DXE is lower, as I told that, the complexity of the data modeling is reduced. You can bring the semantic rich data from your SAP Business Suite to HANA. Okay, so application logic, what you write in your backend system can be brought to the HANA system using the different methods of DXE. Then lower total CO, total cost of ownership, because it already reuses the existing proprietary functions, transformations, and load mechanisms from ABAP. So no additional work is done, only few minor steps which needs to be done. No separate installation, no separate server for replication like you have for BODS and so on. You can always very easily capture the CDC or the delta part of the table while doing the configuration itself. And also there is a mechanism to properly handle all the data from all the delta processing types. So based on the different types of delta, you can process this data and get the response out of it. Okay. Now, DXE uses the NetWeaver extractors, or the data source extractors, which are already present into your SAP Business Suite system. You can always create your own extractor, and you can use it for transport of the data store objects. Okay. So important thing to remember is that DXC can be installed, or the DMIS package, DMIS add-on, which is installed, will be on the SAP Source Business Suite system, example your NetWeaver 7.0 or onwards, and SP19 for Service Pack 19. So this has a 2008 available, and you can use it furthermore with the more DMIS add-on. Okay, so it's not very too complicated to do that part, and the one of the best is no additional servers, no configurations required. Now this is how the DXC flow will look like. So how do we bring data into the source system in our ERP system? Anyone of you?
Sorry, Abbas.
How can you bring the data from any source system, Oracle or MS SQL or anything, into your ERP? How can you bring the data from your ERP into your BW system? How usually you bring your data? Do you have any idea regarding PSA and the process chain and the DTP? From the ERP system, we use extractors. So these extractors can be used to do a transfer of data from the ERP system to the BW system. So before going to the BW system, it reaches the storage of the BW system, that is called as the PSA layer, or the persistent storage layer, persistent storage area. From there, once the data comes up, then your different modelings for the BW starts. Okay. Now, what happens in case of a DXC is the DXC tries to cheat the system and tell that, okay, the DSO don't go to the PS area, instead go to SAP HANA. Okay. Now, here what will happen in this case is your ERP data is brought using your extractors or the flat structures, and these extractors go through the DTP, and when there is generic DTP is required, then these extractors will be used to transport the data from your source system to ERP system, or even the source database system to the HANA database. Okay. So anyways, so once this data source skips this DTP and comes to the HANA layer, it becomes as your in-memory DSO. In-memory DSO has a lot of components like activation queue, active version, status, and so on. So this will provide you information about what table has come up, what is the state of the table, what is the confirmation of table or not, and so on. Okay. So this is a process, exactly the process which is controlled by data warehousing. So like when data is extracted from SAP Business Suite, it is not loading the PSA, it is redirected to new SAP HANA. It gets loaded into the memory's activation queue, and then gets activated to form the active table. Okay. So in the data load monitor of the embedded BW, it will still show that the data load from the activation queue is done through a, guys, anything from your side? Okay. In case of a data load monitor of the embedded BW, it will feel like the data load is happening to a PSA. It will not feel like the data load is happening to the SAP HANA. So in short, we can say that the load monitor shows the source connection, and then you can always say that what data has come up from the replication. delta processing or the change CDC. So in case of this, so it works in a similar way as if the target system is a VLU system. Okay, and if the data source is delta enabled, then the delta data is available with SAP HANA with minimum changes. Okay, so this can be configured during your extractor configuration, and then you can check that during the replication. How is it brought from the source system to the target system? So how does a DXC works with in this case? Now DXC will be using XSJS of HANA system, the extended JavaScript of HANA system, to connect to the DXC through the Internet Connectivity Manager. And this ICM will receive the XML inputs from the XML packages from the HTTP connection. And then once we read the XML package from the XML connection, then this engine, this XS engine will remove the data package from ICM, create the functional or convert the formats, and insert the records into the data store object. So once this data store object is activated, then this DSO object will become your in-memory DSO. Now these are the steps which you need to use for creation of a DXC and configuration of that. So first thing first is DXC configuration. Okay, now in the configuration inside your daemon.ini, once you expand it, so make sure that you have your web dispatcher running. So web dispatcher is running, so that is what we should be looking at. Second is your XS engine is running. Okay, now second part is you need to go to the components of XS engine, and in the component application container you make sure that you have libxsdxc as part of this. Okay, so once it is there, then only we can use the libraries of DXC to make the connection. Now click on save, and then fourth step is to import the delivery unit. So import SAP HANA content, then delivery it, then click on next, choose a system which you are user. And from the server, you can choose the file which has hana.dxe.tzz name. Okay, so click on finish. So automatically it has been done. So I will not reuse that again. So when you click on finish, it will automatically activate the views. Okay. Now I need to go to my content. So we need to find out this path. So slash SAP slash HANA slash DXE slash So this is the path which we need to check, and we can once we have done the configuration from the HANA side, we can check the configuration whether it is working or not. Once we click on this, so we can see that Exchange is up and running, and you can write this the path, then click on next.
Is there a typo? SAPA, take off the A?
Oh, okay. Sorry. Then if it is correct, then we ask for the user. Now we can see that our DXE is up and running. So this service is configured in HANA. Now we have to do a similar configuration in your backend system from which we want to connect. So for that, we will go to again our RFC connection, and we'll choose our HTTP connections to external server. So here I have already created that. So you can use DXE HANA. Okay, and here you can see that you give the same server port number, service number, then the path prefix, you can log on security, okay, and you can do the test on that. So once the response is 200 or okay, that means your server is up and running. Or you can simultaneously check whether what is the response is coming from the server. Okay, so now the RFC connection is also set. Just keep this as a new notepad. We have to do certain more settings. We have to go to a table and see what is the value of those content of the table. So we have to go to RS admin and check out the content for the tables entries which have the PSA entries. So here we have done PSA to SDB is global, and PSA to SDB data source is ZDXC data sources. Okay, and DXC underscore HANA underscore RFC. So this is the RFC which we are using, and the schema, the HANA schema, which we are using the HANA schema. In case if it is required to modify this settings, you can go to a program, SAP RS admin underscore maintain. Then you can click on this and you can maintain the table values. So you have a PSA to SDB schema, PSA to SDB data source table, PSA to SDB destination, and so on. So once this all the configurations which are done, then the next step will be to create an extractor to move the data. So here also we have similar steps. So now we are going to show the content of the S-Lite. So we have some data in my S-Lite table. So we will, once this configuration is done, so like your PSA to SDB, PSA to SDB destination, then we'll create an generic data source maintenance in your embedded BW. So for that, we use a transaction SBIW. So then here we'll create a generic data source, and we can say it is an S-Lite. Okay. Now you can also choose to extract the data from your view or a query or a function module. So based on your inputs, you can choose so where you want to keep it. Suppose I want to keep it in some container of my package, so that I can retrieve it. So SAP R3. So I'm just going to keep this into this component, and I'm just saying that it is S-Lite DS. Okay. Now what table I want to work with is, so suppose now I have selected table. Now I want to work from query, then the query will get enabled. Or I want to work from a function module, then the function module will get enabled. Okay, so as of now, we'll work with the view. Once you are saving this, it will ask for a package name. Okay, then you can assign it to a local object or the TMP package. Now I need to go to my regular modeling environment. In this modeling, I have source systems from which I bring the data, and data sources. Here it will give me the list of all the available data sources from each component. So it might take some time. Now in my SAP component, we have put in the SAP component master. So this is a component where I had put my extractor. So I'll right click, then replicate metadata. So once I do that, this the extractor which was created in your ERP system will be loaded into your BW system. So it might take some time. So once you get a pop-up like this, so it is asking that it does not exist in the BW system. How do you want to create? So we choose the option that we want this to be created as a data source. So click on OK. Once the similar steps have been done, so you can go to RSA, then go to the application SAP component application and choose the folder or the package where we have created it. So once you have created, you can right click on this and replicate metadata. Okay. So once you have got this dialog box where it is asked to you that which type of data source you want, you can choose RSDS or the data services data source ready button. Okay. Once you click on that and click on choose change, then we need to activate the DSO. It's taking a lot of time. Now my S flight has already come up over here. Okay, so now I will right click on this and click on change, and I will enable it for editing. So once it is enabled for editing, then I will activate this. Now it shows the version as in processing, and you can see what is the user, what is the change language. Then from the extractor point of view, you can see delta only via full load. So there are various other delta options like after images with like add, or main delta with unspecified by extractors. So many, or info cube extractions, many more methods are there. Okay, so then fields you can see, and the properties if you want you can see. Okay, so once this is information is available, then you need to activate this. Once activation changes, I think the system is a bit slow today. Okay, so activation is going through. So activate PSA BIC underscore this. This is taking a lot of more than the usual time. Okay, so let's meantime I'll explain to you the next steps. So once this DSO has been created in the SAP HANA system, so you can check the DXO in the schema which you have configured. And the data source is activated. So now my S flight table has come up, and there will be this 4 tables along with the DSO in memory log will be generated. So these are the 5 tables which will be coming as part of this cube. Sorry. Okay, and these 5 tables will be named accordingly. So suppose here you will have the ADS is the source of the table name. So ADS 00. So this is the active data table that stores all the data loading into the IMDSO. So if you see this 00 is the active table which will be loaded. So it will contain all the related information from the S-Lite, and you can also do a data preview on this. Okay, so as of now nothing has come up. Okay. The second table is your number 40. So this is the activation queue table. So when a DXC extraction load job runs, so this is a total activation queue, and here you can see okay, so there is no activation done, so maybe we can just quickly check that part. Okay, now we'll have to first bring some info package, create an info package, and then you need to save this info package so that we can get some data and scheduling the initial data load. Okay, so again we'll go back to the RSA one. Okay, and if I click on this and create info package. Now here you can create an info package name. Okay, and we'll just say if. Click on save. Once you have done, on the schedule tab, so once this info package is created, so on the schedule tab, you can start the data load immediately, or you can start in some other time. Okay, so if you want, you can schedule it and execute the schedule of the data. So now the data will start loading into that immediately. You can also see the jobs which are running. It has caught an exception from your SAP HANA program. Looks like we need to again contact the administrator for this. The issue regarding this cannot be solved from a developer point of view. So this seems to be some admin related concern we have. Okay. So like there is an exception from this program. So idea is that once this your info package creation is done, so you can just do the start of the loading of the data. Once you are done, then you should be able to see the data in your empty tables. So these tables, you'll start seeing the data. 00, you'll start seeing the data over there. Okay. As of now, it is empty table because the flow did not happen, and so this is something which we need to check with the admin. And these are the 5 tables which I told, which will be generated. So suffix with 00, suffix with 40, suffix with 70, suffix with 80, and suffix with AO. So these 5 tables have the significance like this. So 00 is the active table which will store all the data that is loaded into in memory from the DXC. And this is table which you will use for your data modeling. It is a columnar data, and which can be used for your any kind of modeling scenario. Suffix with 40 is the activation queue table. So when a DX extraction load job runs, it loads the entire series of the data packages, and then in sequentially or step by step it will start the activation of the tables. But in this case, we had less number of tables, so it got generated completely easily. Then you have 70 and 80 and AO. So 70 is your technical tables. 70, 80 and AO are all your technical tables which are used to control the activation process. 70 is a delta table, 80 is a history table, and AO is a status table. Also remember that even if this gets suffixed by the number or 2-digit characters, it also prefixed by A. So in all of the views you will see /BIC/A. So this time metadata has been created. It should ideally create the tables and the info package activation is completed.
All right, let's test your knowledge. Here's a question for you. What enhancement was made to smart data integration in SAP HANA 1.0 SP12? Option A, real-time replication from SAP ECC. Option B, parallel processing of transformations. Option C, support for Hadoop integration. Option D, enhanced data masking capabilities. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, ready to dive into the world of SAP HANA 1.0 SP12? Our course is your ticket to mastering supply management. You can learn at your own pace, right here on our platform. In this course, we will unpack SAP HANA 1.0 SP12, the ultimate toolkit for planning everything, from ensuring we have got enough products to get them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors? They are pros with years of experience, dedicated to helping you learn and answering all your questions. And guess what? Our students love it. Just like you, they have found our course incredibly helpful. The best part? It's super affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA 1.0 SP12 Pro? Sign up on our page now. For more info, visit ZaranTech's website.
Next is your data preview. So once the data is uploaded in using your server, then you can always go back and check into the server that if the data preview is fine or not. So coming to landscape transformation, so I think ideally I should be waiting, but so SLT is another part of the replication tool, which is basically not an ETL tool and focuses completely on the transformation time or completely on the replication time. So in this unit, we'll learn about what is the architectural foundation of SLT, or what we call as SAP Landscape Transformation, or SAP Landscape Transformation Replication Server. So all these three terms are used equally and all refer to the same technical aspects. So then we'll see also about the configuration of SLT for HANA, and also if the system is back, then we can also see the configuration, the data provisioning in HANA Studio, and how you can trigger an initial load, or when do we use SLT. So SLT is used when we have only SAP systems as a source system, or we have very few non-SAP systems like Oracle or your IBM DB2, DB4 and DB6 are some of the systems which are accepted by your SLT as part of the source. So So SAP Landscape Transformation has also called as SLT. It is a real-time replication tool for SAP HANA, and the one of the best part is that it resides in HANA Studio. And so SLT is based on the concept of the DB triggers. So it creates a DB triggers in different source system for different files, and it will bring the data from the different sources. So now let's see that what are the components which will be created, or what are the triggers which are created as part of the SLT replication. So the first one is a read engine. So read engine is basically a major component which will read the data. So either the read engine can be in your source system, or it can be in your replication server. So when the read engine is in SAP applications, then it is a DB trigger which is present in the non-SAP applications like DB2, DB4, and then we can see what all data is being consumed or being replicated, which one is in the real time, which is not in real time, and based on that symbol, so we can classify the runtime of the data, and hence the data which we need to bring it. Okay, so now we have three types of components of replication server. First one is your read engine, second is your transformation engine, and also it uses the basic and the basics, and then we have mapping and the transformation engine, so which will basically perform the mapping and perform the transformation or any such kind of changes which is required into HANA system through write engine. Now write engine connects to HANA system through through the DB tunnel, and this tool is embedded into the HANA Studio, so you can very easily work on some things and very effectively get the response from the SAP and non-SAP systems over there. Okay. So let's first see what are the advantages you can get. So it's a real-time replication server, so we are able to migrate the SAP ECC or some of the non-SAP applications from R3 system to even your ABAP based HANA system. Okay, so another thing is like it handles cluster in the pool table. So this is an advantage over here because DXE cannot handle cluster and pool table, and even for cluster and pool table you need to that is also feasible in your BODS. Okay. Only demerit I can see in for BODS is that it is not connected well. Second is that you need to create a configuration. Then configuration steps are much more compared to the regular other tools, and like in SLT there is very less configuration, in DXE very less configuration, in procedures there is a bit of configuration which needs to be done. So another advantage of using SLT is so table settings such as filtering data, enabling rich structure, and read data anonymous is also in the feature. So even if you are in Drive or if you're anything, then you can check this part, and you can work on the SLT at a very fast way. So SLT is a much more simpler to implement compared to BODS, and it is a real-time replication method. Also from Solution Manager 7.1 SP5 onwards, you have enhanced monitoring capabilities of SLT, and you can also see what kind of data movement is happening, what is a query, and other details. So there are two types of data movement in SLT. First is load and second is replication. Load is basically a one-time copy from a source system to the target system. We call this as initial load, and this is not a replication, but it is a bulk copy of the data from the source to target. So this is very important because sometimes when we build up a new system, we need to bring up all the data, and that time we don't want the replication, every table-to-table replication. We just want majority of the data to be in SQL format or in the through the SQL way. On other terms, replication basically means first an initial full load, then immediately sets up a real-time replication of data from the source to target. That means it constantly monitors the source table, and whenever there is any changes in the source table, automatically it will get reflected in the target table. So what we can say is that replication part or the SLT is able to bring up the data in a very fast environment in a real-time method. Okay. So SLT is also used mostly in a sidecar scenario where we are using SLT as and we are taking MySQL as a database, and the copy of that database as taken as your okay. So the SLT can replicate the data from the source system to the target system at the table level only, but in BODS can work at the other levels like ODS or even at application or any other means, but SLT works only at the table level information. So what are the use cases of SLT? So SLT is not meant for a heavyweight transformation or heavyweight replication and so on. It is meant for quickly call up the table from the source system and replicate that table into the target system. That is the only purpose of SLT as of now. So we can do certain modifications of the data when we bring from source to target, like we can add and remove the table columns. You can change the data type for a column, like integer to float or a string. Okay, so you can change the data type. You can do filtering on the data. You can modify the data for column values to align to other systems. When different languages are used, then we can modify the certain columns to maybe describe the data in the local language. Then we can split up a table for partitioning, and SLT enables your distribution of data from a single source to a multiple HANA source. Okay, then what is the background of how these operations are performed is through ABAP, and all the transformation logic for SLT is to be written in ABAP. So if you have an expert knowledge in ABAP, then you can write your transformation requirements, and based on the transformation requirements, you can use ABAP to work on those transformation requirements. So this is basically the architecture for SLT, where this is a SAP system. The source is an SAP system, and we want to bring up some table from our source system to our target system, that is HANA. So for that, first we'll create a configuration between the source and the target, and this configuration allows you to import data by this amount, and you can bring the data into HANA system. So what are the prerequisites for this? There is an add-on, that is a DMIS add-on. So this is needed to install the configuration of SLT, and the replication server should be more than 7.02 ABAP stack, or for kernel 7.2 ext. So in this case, we have a minimum requirement of the server, and so what happens when we are using SAP as a source? In this case, the application is placed almost at the end of the So now what happens when we have an application table? So we create the login tables, and we create the read modules which will constantly monitor this application table. Now once this configuration is set, how many users you want, how many flows you want, what is the connection type, and so on. Then using the RFC connection, this data is sent over to your replication server. Replication server in turn, yes, we will push this data into the replication server through DB database component. Okay, now coming to the tables. So even though we have the write module and the controller module in your replication server, but for some cases when the source is not a SAP source, in that case, how should we do that? So in that case, we either bring the replication server and write the modules in the application server, and then connect and see if that works. Okay. From the architecture point of view, the DB layer, the non-SAP source system will not have the triggers into that, because it is a not SAP system, and hence it cannot be manually created over there. So we do not have triggers in the SQL part, and these triggers are basically in your replication server, where you have different types of modules. So write module and read module are there in your replication server itself. Now from the replication server, so there will be controller modules, there will be read modules, there will be write modules, and all the three relationships can exist together in the same server. And okay. So one thing to note over here is, in the previous example and this example, earlier we were using from your replication server to your source system, you have RFC connection, and also the read module is present in your source system. But in some places, T-Mobile or some other places, they will not have this as the RFC connection. Instead, they'll have a normal DB connection. Here also there will be normal DB connection, and you can have you can have this DB connection to get the data from the source to target.
Hey there, ready to dive into the world of SAP HANA 1.0 SP12? Our course is your ticket to mastering supply management. You can learn at your own pace, right here on our platform. In this course, we will unpack SAP HANA 1.0 SP12, the ultimate toolkit for planning everything, from ensuring we have got enough products to get them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors? They are pros with years of experience, dedicated to helping you learn and answering all your questions. And guess what? Our students love it. Just like you, they have found our course incredibly helpful. The best part? It's super affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA 1.0 SP12 Pro? Sign up on our page now. For more info, visit ZaranTech's website.
Next topic is SAP Replication Server. So we do not have any demo for the replication server because we do not have a configuration for that. And in this session, we will just give you an overview of the replication server and the mechanisms of the replication which is used in the replication server. Okay, so in this unit we'll understand that what is a replication server, or if I say about replication server, it commonly refers to Sybase replication server. Okay, so if I just say in normal terms, if you have SAP replication server, it is meant for Sybase replication server. SLT is also LT replication server. Okay, so these are, let's not confuse this part. So SLT is your SAP LT replication server or SAP landscape transformation. So in terms of when it is meant SAP replication server, that refers to Sybase replication server. Okay. Now, so what are the business use case of using a Sybase replication server? One of the main advantages of using a Sybase replication server is that it can connect to a wide range of database vendors, and this in turn is much more helpful because it uses the log-based mechanisms, which is quite fast compared to the other methods, and it almost like acts like a real-time replication method. Okay, so what is an Sybase replication server? It is a sophisticated transactional data movement, okay, that moves and synchronizes the data across enterprises without geographical distance limitation. So even though one server is present in one end of the world and another server is present at another end of the world, Sybase replication server is quite fast, and it also guarantees data delivery, real-time business intelligence at zero operational downtime. There might be some delay in the SLT configurations or SLT replication, but it is this Sybase replication server is quite fast, and also it allows non-intrusively handling of the data at the source and the target system. Okay. So one of the reasons for this is because Sybase replication server captures only the data changes. So there is no impact on the application which is already running on the database. Hence, it is called as non-intrusive handling of the data. And based on this, since it captures only the data changes, so replication server can be used in any database system. And some uses of the replication server are to facilitate migration of database, complete migration of a database or application that requires significant downtime. So in those cases where in SLT you have configurations of limitations of the number of calculation jobs or initial views, or in case of DXC you have to make extractors for different tables, and you have to activate those extractors. That takes some time. But in case of a Sybase replication server, it is very non-intrusive, and you do not have to do a lot of configurations for that. Now, the business systems what we usually work are OLTP oriented, with primary business events in the form of database transactions. And analytics do not work very easily with the OLTP workload. So in that case, when we don't have to stop the OLTP workload and we want to replicate the whole of the database system, so Sybase replication server comes up in the picture. Now, what are the advantages of Sybase replication server? So Sybase replication server is a log-based mechanism and it replicates the committed database transactions. So a built-in replication agent continuously monitors the database transaction log for any committed transactions that have been marked for replication. So once these committed logs are found, it sends it to the replication server, and replication server will forward the transaction to the target system. Okay. Now other based are like it has a very high performance. It improves recovery and resumption times and minimize downtime. Okay. Third is like it is bidirectional replication. In most of your replications, you will see, except in BODs, that you can only do from source to target. But in Sybase replication server, you can also do from source to target and as well as target to source. Okay. Now, other advantages is like you have an additional replication server which can also be used as a standby database. Okay. Now, another advantage is like you can do real-time data sharing. Okay, and like there is no need to have a downtime of a system. You can completely copy whole of the primary database to a secondary database. You can enable remote applications to access the data locally. Okay. Then fresh data is to be enabled at a timely decision. So you can run the resource intensive reports on the standby server and at the backend allow the replication to continue. We can also reduce information latency for reporting and optimize the batch reporting. So there are many different advantages you can see with a replication server. So what are the examples of the scenarios we can look at the replication server? So one is data distribution and migration. So you can distribute your centralized data from a transactional database to a reporting database. One, you can share data between the operational applications. You can maintain the synchronization between the overlapping data values. We can migrate the whole system maybe from an older database to a new database. Okay. You can do a real-time decision support using operational data stores. We can do real-time loading of the data warehousing. The complete data warehouse can be loaded. Okay. Then we can do real-time data sharing and synchronization. Like we can do application availability during unplanned downtime and so on. So that time the standby server will act as a reporting layer. Okay. Also, additional benefits you get is bidirectional reporting and bidirectional replication. You can also move or replicate data from your target system to your source system. It has one is to many and many is to one operation, unlike in your DXC or in your BODS. BODS can have one to many, and SLT can have one to one replication only. But in this case, Sybase replication server can manage both 1:1 and 1:many replication. So what is the supported database in the server architecture? So you have Sybase ASC, Oracle, Microsoft SQL Server, IBM DB2 OS 390, then Business Suite running on Sybase ASC, Oracle MS SQL running on DB2 UDB, and SAP HANA database as the source system. Then the targets can be your SAP HANA system, ASC, IQ, Sybase Event Stream Processing, Oracle, MS SQL Server, IBM DB2, DB2 OS 390, and so on. Okay, this source system is called a primary database, and the target system is called as a replicate database. So in this case, you'll see that a wide range of supported database or enterprise applications are supported, and hence the data movement between this type of applications becomes very easy. Now, Sybase Replication Server also includes something called as your replication agent, or what we call as so this is a lightweight server. So when we are moving from one source system to a replicate system, both are HANA, then we can use a replication agent for HANA. So this is a very basic about Sybase replication server. We just included because sometimes it is asked in certification, what do you mean by SRS, or what are the different type of sources, what are the advantages of SRS, and so on. Now let's move to the new topic, which is SAP Smart Data Access. So SAP Smart Data Access is a quite new tool in SAP portfolio, and it provides a lot of different advantages over the compared to your regular other databases. So one of the main concepts here is the virtualization concept. In all of the previous tools what we have discussed, we actually need to physically bring the tables in HANA system to work with the tables. What if I have huge tables outside HANA, like your big data system, Hadoop system, MySQL system, and we cannot put that amount of big data in our local system? In that case, we use a concept called virtualization concept, where we bring only the metadata from the targets from the system and bring it in HANA, and during the query time, the data will be fetched. There will not be any physical table which will be implemented over there. Only the metadata or the structure of the table will be kept. Data virtualization means like in your replication, we do not have to physically bring the data from a source system to HANA. What we mean by it, that we maintain a connection to the our target system, and instead of bringing data into HANA, we only bring the metadata, only the structure of the tables. During the querying of the data, that time the whole of the data is read from the connection.
You were saying only like transfer the structure and when
bring the structure in the system, so that we can start modeling, we can start working on the combining with other tables. And whenever there is a query on this particular virtual table, so this virtual table will be having the metadata of the table from the target system, and during this query of the virtual table, that time only the data will be picked from Oracle system or MS SQL system and put into HANA. Meantime, we'll understand SDA. So if we are able to get the server on hold, once we complete that, then we can see Smart Data Access also. Okay. So, or else I'll try to show you another server. Okay. So in case of a Smart Data Access, the concept of virtualization implies, and we do not actually bring the tables. If you see here, we have our HANA system where we have some of the existing tables. Now we can connect to Teradata, Hadoop, SAP HANA, Sybase, SCIQ, or Oracle MS SQL, and bring the data from these systems. So some of the systems are column-based, some of the systems are row-based, and we can bring this metadata from these systems, combine them with the actual HANA tables.
Okay. So that virtual table is the structure, as you mentioned.
Yes.
In the middle part, that's the only structure.
Okay, it does not contain any data at all. There is no physical movement of the data now. Okay. So one of the best examples is, one of the best use cases is that we can get a heterogeneous systems like Hadoop and Teradata, which do not have the data mostly in the enterprise format. So basically we can combine the structured data along with unstructured data as well. Okay. So another advantage what you get over here is, okay, thanks Tony for the information. So another advantage what you can get is, first is your heterogeneous connectivity of the data. Second is remote real-time query processing. The query processing happens from HANA and it is in turn sent to the remote system for getting the data. Third advantage you get is secure access to the heterogeneous data sources. You have additional layer of security to connect to the heterogeneous data source. One more advantage is, which is not very known in other systems, is if you have any DML operations, insert, update, or delete, or any such IUD queries, that you can put it on your remote system, and this in turn will get impacted at our source systems of Teradata, Hadoop, or SCIQ. This feature is not available in many of the data provisioning techniques. So this data virtualization becomes a very strong way of pulling a lot of data at the runtime. Some of the demerits what you can get is, since the data is not present in your HANA system, so the query time will be much longer compared to a physical table which is present in HANA system. So that is the only disadvantage what we can see as of now. Okay. So this is how the data virtualization concept happens. You have enterprise data available from your SAP system, and you bring Hadoop data or Hive data from your secondary storage. This is let it be OLTP system, and let this be the big data system. That you can combine both the data sets in SAP HANA using Smart Data Access. Okay. So what we can do is we can leverage the use of enterprise data like from your ECC system, combine it with predictive or text search or geospatial, and put it with Hadoop data, process the big data, and create some models on top of the combination of this data. So this can be achieved. So what is the outlook of Smart Data Access? It has a support for data sources, heterogeneous data sources, and also the SDK for that. Then it has very strong Hadoop support. It has a strong performance on the query optimization and performance. Data caching is possible so that if you're loading the same data again and again, so you can actually bring the data into HANA system using data caching. Data transformation cleansing can happen during the transaction. Monitoring and recommendation of the jobs can be done. Expanded DML support for some of the sources are available, like your delete, modify, update, and insert. So those things can work out with some of the databases, supported databases. So this is a concept of virtual table. So from your remote sources, you can create a virtual table this virtual table is always connected to the remote source. And if I need to work, I can build up a view or a model based on the combination of the HANA tables and virtual table. Now this combination can be used to send to an application or can be used to create any calculation view and so on. So why Smart Data Access is better than a lot of other tables, a lot of other replication methods is because, first of all, easy to set up, very less configuration required for this setup. Second is no need to load the data from the source to start the project. You can directly work with the metadata only. Maybe the data can get updated later on and it can come. Third is your very high query optimization to leverage the processing capabilities of the target system, and also to move the minimal set of data between the HANA and the sources. Another advantage is that we can leverage the big data processing and convert the big data format into SAP HANA format. So we can very easily integrate HANA system, the ECC tables to the big data tables. Then we can access the remote data much more securely with additional username and password which we give. It can also help us in the data archiving. So since it does not take much of a space, so we can store the hot data in HANA and warm data in disk-based system like IQ, and it can have a continuous access to the target system with this. And whenever we want, we can do a query on using the warm data. Okay. Another thing is queries in HANA can integrate directly from the queries from IQ. So you can get a query from HANA and you can get a query from IQ, and they're connected. You can always execute those queries together. So this is some slide which you can read by yourself, which is like how it is non-disruptive and what is the data virtualization, how the data decision making happens. Another advantage of Smart Data Access is that you don't need any additional servers. Your HANA system, the HANA database itself will act like the server on which you can install your Smart Data Access components. For Smart Data Access to work, you need to install the ODBC configurations in the HANA Linux system. Okay. That will be done by your administrator. So to work with the Smart Data Access, so you should have this configuration running, that your enable remote source capability should be true, cache validity how many seconds, okay, and this properties like virtual table format, virtual table cardinality. So this configuration should be available, okay, and if you want, you can enable the remote cache as well. So now the remote cache is working fine. So how do I access the Smart Data Access? Is first I need to, there's another node apart from catalog content user, that is provisioning node. So in this case, once you expand provisioning node, you'll see two child, that is one is Smart Data Access and another is a remote sources. So remote sources will contain the list of the sources which can be used for connectivity. Okay, so as of now, we'll connect to our own HANA system and then see how the connectivity works. Okay, so right click on the remote source, choose a new remote source, and here you can give okay, so give the name, then you choose the different types of ODBC adapter. So Smart Data Access works on the adapter properties of ODBC, and all the configurations are kept in your ODBC configuration using the ODBC adapters. So these are the different types of systems from which you can pull up the data. We have ASC, we have Teradata, we have IQ, HANA, Hadoop, generic ODBC, Oracle, ODBC, MS SQL, Netezza, DB2, MaxDB, Hadoop, Spark, SQL, and MII. So we have different types of configurations available over here to work with them. So as of now, I'll connect to a HANA system. Then once you connect, then you'll see these are the connection properties of the connection. You don't have to do much of the things. And which ODBC will contain the data for connection is this one, lib odbc sdb.so. So this will contain the configuration, ODBC configuration for the replication of the data. Now, second is your configuration. So these fields which are marked in the pink color are the fields which are editable fields, and they have to be provided by the modeler. So what server we are using is best server. So we'll connect best server. Then what is the port we are using? We are using 30315. Then whether you want DML mode to be read-only mode or you want it to be read-write mode. So DML statements can be written to the source system. Then you can give the technical username. So we have HANA as a username. So make sure that in this case, when you're saving it, just after inputting the values, press enter so that this value is taken. Now my remote source is created. Let's see whether this connection is active or not, or this is working or not. So there's an option of test connection on the top right. So click on that. Now, if it is working fine, it will show that connection to the source system is working fine, and you can start using this. So I can go to my remote source, expand the remote source. Here I can see the database name, and here I can see the schemas. So some of the schemas you already would have used it. Like we do have training schema. Okay. And we can bring up any table. Suppose I want order details, or I want Mara and MAKT. So I'll create a virtual table. So choose this add as a virtual table. Now here you want to use this name. So this table name is automatically created. So this is the name of the table which you have brought. It is prefixed by the remote source name. It is not mandatory to have like this. You can change the remote source name anytime. Okay, so I will let it the remote source name like this. Then I'll do create. So the virtual table has been created. Similarly, I'll create a virtual table for MAKT. Now let me go to the schema. So you can see that two virtual tables with a pipe kind of symbol has come up for the Mara table and MAKT table. Now if you see the definition, it will feel like a normal table. There's no change in the system, but except that the type is virtual and the source is the same. Okay. If you will do a data preview, that time it will start fetching the data from the system, and that time only during the runtime it will bring the data. Since we are connected a remote system to this own server, so hence the data retrieval is very fast now. But in case if you are connecting from a distance server, then data content will be depending on the, or data request will be depending on the depending on the location of the target system and depending on the what kind of target system we are using. Okay. Now you can use these tables to combine them together with some of the tables and create a calculation view. Okay. So you can create a new view or synonym, or you can do anything extra or even generate some visual SQL on top of this. So let's just create. So this is how you can bring up the table in as a virtual table, and you can work with the data of the virtual tables or along with the normal SQL, and you can work with the normal tables to get the join between the tables and so on. Another aspect of the virtual tables or remote source is the provisioning or the smart data access options. So you can open the smart data access administration, and then you can see what queries are fired. Okay. What is the connection which is running? So as of now, we are having up to the connection, which is for HANA self underscore RS. What are the parameters we can use? That will be open the configuration and data monitoring. We can see that we executed this query, and at this particular time, and the execution time was how many seconds? Oh, sorry, how many milliseconds, and whether the connection is still active or not. So connection is closed once you have closed the query execution. So this is how you can do the monitoring of the remote source, how you can see what is a query which is executed, and at what time who is executed what query, what is the current connected system, how many systems are connected, then you can work this one. And then you can see any configuration which requires any system parameters, that also you can do that one. So here we have done this part of value threshold, how many joins you can have, and so on. So those things can be configured. So this is the concept of the virtual table, where we bring the source from some other system. Simple thing is, we have to create a remote source. And how do you, it's just like your RFC connection. Okay, what we do in a BW system, or what we do in some of the replication techniques. So you just maintain the connection. So if I see these connections are live, and you can see the definition of these connections. Okay. So you can maintain these connections, and these connections will be stored and as part of your ODBC connections. And using these connections, this query will be transacted. So this query will be performed like selecting from the virtual tables.
Once we maintain this connection, means table structure should be ready.
Remember what we have seen in our creation of a data source in BODS? We created a connection as a data source, and we could expand it to see all the data, correct? So similarly here, once we maintain a connection, so we can expand it and to see what kind of data we have in the target system. Okay. So once you create a connection, to show you only the list of the database, list of the tables that you can work with. Now it is like we are connecting from HANA to a HANA system, but in case if you connect to any Oracle system or MS SQL system or another things, like here the SQL system is not working, so that time we can able to see the data for that.
What about the 100? 100 is a totally different database. It's unstructured, right?
Hadoop is, yes. So Hadoop also, if you want, you can just use the data source name, which will be given by your admin provider, and then you can use the username and the password. Then Hadoop's unstructured data is converted to the structured data format for HANA.
That's good. When we should use the smart SMA? What kind of use case you mentioned?
We should use Smart Data Access SDA only when we are we do not want to bring the actual table, whole data. We just want to bring the metadata. So we do not want to store the table. That is one main concept. Second concept is like when you want to connect very easily with Hadoop and other adapters, which need not have any separate installation, but only a small configuration is required.
So one question, so the virtualization, what is the difference between virtualization and federation?
Virtualization and, sorry, I did not get your last word.
Versus federation, data federation.
So it is a similar process.
Same, right?
Federation was an earlier known name for Smart Data Access.
Yeah, we can also able to connect Hadoop with data information, connections thing like Smart Data Access, and
you can connect to your Hive system using this. Now let's move to another topic. Now we'll start with the reporting. So we have completed the data provisioning topics. So
you were mentioned we are going to learn like SAP, like HANA Live and the CDS, right?
We will learn. Don't worry. We will learn about that part. I'm just keeping the advanced topics for the last. So once we complete the reporting and once I'm back from my assignment, then we'll complete for HANA Live. Not an issue.
How we can better prepare our certification? Is that like have some question answer that we can practice when you are on the project?
I suggest that first you go through all the content what you have, whatever I have earlier given you. So in the drive you can download all the content and start reading all that. There is a lot of notes which will be mentioned, especially with related to versions or limitations or extra use cases or anything. Okay. And now first for what are the various stages of preparation you should do. First is your basics should be clear for one specific topic. Okay. SAP focuses a lot in their certification on the features of the tool. Okay, like ABAP data flow can be used in which of the tools. Then it lists you all the replication tools. So this is a feature. ABAP data flow is a feature of SAP BODS. Okay. Then the data virtualization or the data federation can happen with which of the tools? Which are the tools which will use data virtualization concepts?
Smart data access.
Smart data access. Okay. Then you have another different. These are the different types of questions which will be coming up, and the first stage of preparation is to know the features of the tool. Okay, that is the first stage. Second stage is your more deeper learning. So deeper learning will come up with the practice. So for a HANA certification, they do not have much of a very scenario-based situation. Okay, but they will ask you certain scenario-based situation that, okay, this is how the model is written and how I can go ahead and perform certain operation. So you need to choose maybe some queries or some additional properties and some additional steps to perform. So that will be asked. Okay, that is the second one. Third is like for a multiple choice questions which has more than one answer, be very careful because the differential marking is available for the question. In that case, you have to check and be careful about what you are writing or not. What are the selections you are making? Okay. Apart from this, we will see some additional questions at the end of the sessions for us, and I'll also provide you some list of the questions. But those questions are a bit old, so the idea is just to give you an example of how the certification questions are prepared, not the actual certification questions.
Okay, so that means it's pretty much we have to count on ourselves to prepare.
Yes, so you need to prepare. You are giving the certification, right? So you need to prepare on those parts. So we'll be there to assist you. And I suggest that take at least 4 weeks of time for your preparation. In case if you're targeting like 90 plus score in your certification, take at least 4 weeks of preparation. And there are a couple of resumes which are present on the on the server itself, and you can see that how these resumes are written, how these resumes, you can fine-tune your resumes using the keywords what you have read, so that you can get a better job prospects. So recruiters, when they recruit, they look only for the specific keywords in your resume. If your specific keywords are there like data modeling, attribute view, article view, calculation view, then your SQL processing procedure, and then SDB table, SDB procedure, and so on, that time your resume will get much more visible to the recruiters compared to other resumes, and hence that time you'll get a much more better job opportunities. So what I would say that there are a lot of contract jobs which are available. So I'll say that in case if you want to make a transition to SAP HANA in terms of technical, then I would suggest that you take up any contract job which gives you a lot of hands-on to the project. Then once you have a hands-on on the initial project, and then you can start applying your knowledge over there. Then you start learning much more better way. Okay, how many years of gap you had from your previous SAP experience?
Less than 1 year.
Then it should be okay. You can always tell that I was exploring other options, and because of your family moved and or some other reasons, you can tell that, or I have to explore. So it's all up to like how much the recruiter wants to hire you. If the recruiter has a very urgent opening which he needs to close, so your skill gap of 1 year should not be matter. In fact, you can be seen as a diverse person who has not just excelled in SAP IT field, but also in other non-technical field as well.
Okay.
So you can always tell that I was exploring new opportunities, and since I came to new city and I explored something new which was of an interest for me, and once I have seen that okay, I can work on these areas as well, I would like to return back to SAP technical, learn new technologies, learn new products from SAP. Like I just recently got trained into HANA. I have some experience on hands-on experience, and I would really like to put this knowledge in practical use with your organization. So you can tell like that.
Does ZaranTech have like a replacement or not?
I think you need to check with the staff whom you're coordinating with. So maybe those who are from US, they can help you out on that part. Okay, from the career perspective, so what I can say is that in the drive there are a lot of resumes. Okay, so you can first of all start seeing the resumes. So you can tell that earlier you were more into functional consultant. Now you want to become a techno-functional consultant. So and you felt that SAP HANA was the beginning step for your technical journey, and since HANA is becoming a central component of every application in SAP, so you got trained into that. Okay, and you started working. So these are like you can say parts review and gather business requirements as from the business side. Then from a technical side, like real-time replication using SLT, experience with information models, stable design, data provisioning, created an analytical attribute view. Then you have created reports in HANA. Then you have created stored procedures, SQL, PL SQL, experience with SAP HANA. Then you have worked with some of the reporting tools which we are going to see. Okay, and you can mention the version. Self-studying SPS 8 for performance string functionality. So these are the different areas where you can mention. I would suggest that use SPS 12. So if you mention SPS 12, there are a lot many companies who has requirements for SPS 12. This is a basis profile. So from the HANA side, what all you know? So you know these many areas like architecture modeling, HANA Studio, data provisioning, in-memory optimization. Then you have BODS. Then you have different types of requirements like carrying the functional integration, latency. Then this is mostly from the basis side. Okay, I'll do one thing. I'll put up more resumes in my folder, and then you can see actually how these resumes are written, and so that you can write. The more technical you write, the more they will understand that okay, you are more technically oriented. Second thing you can always see, since you are a material management consultant before and you have learned SAP HANA, you can also think about S4 HANA in case you want to become a techno-functional person. Okay, so from the S4 HANA perspective, when you are doing simple logistics area, that time you can showcase that okay, since earlier you were an MM consultant, now you are moved into S4 and you're learning new technologies, you're learning new features of SAP HANA. Okay, so you can tell that you're in a career path and a career progression for S4 HANA learning, and you are open to learn new technologies. You are open to explore new technologies in terms of SAP HANA.
Okay.
Does that help you out?
Yes, help lots.
Okay. So apart from that, I would say that if you are a certified consultant, then it puts your case very strongly that when a client is looking for a certified candidate, your resume can be proposed to them very easily. Even though if you do not have a background with with SAP BI before, but you have an SAP MM experience which can be combined with SAP HANA technical experience. So you have functional experience plus a technical experience, which can be very beneficial for the customer. So maybe the customer is selective about that, and you also need to be selective about the customers.
So let's say our training get finished like next month, because you have to do your project. Will be some time off from us. So let's say next month sometimes around, and then another month prepare the certification. Then I'm thinking probably this year hard to get back to work because close to Christmas holiday.
No, one more thing. See, one more thing can happen. So, see, if you are keen on preparing for certification, go for it. At least it will enable you to learn the topics at a very deep level. Okay, so that in turn will help you for your interview questions. Okay, so that is a double benefit you can get. Second is like meantime, when you start preparing for your certification, you can also start preparing for your resume. And once you have completed your written all the key points in your CV, then you can start looking for jobs. In case if you get a call from the recruiter or for any particular project or contract or any other thing, then you can very confidently answer those questions in the interviews.
Okay.
They will also see that you have a potential to learn new technology at a very fast rate. First, second, you are transitioning from your functional side to a technical side, so they will also respect that part. That now you are becoming a techno-functional consultant, not just restricted to one area of SAP, but also exploring other areas of SAP. And by the way, the highest paid consultants are the techno-functional consultants.
Okay, I'm not looking for high pay. I just want to get on the field. I enjoy the HANA. Just want to get, as long as pay is reasonable, it's okay.
So in this, just to conclude that, so the virtual tables can be used along with the physical tables. Okay. Now, also one thing, remember we have done a migration of the objects. So in this, there was an option to copy as a calculation views and select an option if you need to use virtual tables. So if you're using virtual tables, so in your attribute view or in your analytical view, automatically they will get converted into your calculation views and use a virtual table on top of it. So this option is also available that if you build a attribute view or analytical view on top of a virtual table, you can still convert them to your calculation views. Okay. This is your modeling with a virtual table. You can open your remote source, and from the remote source, you can choose which table you want to work with, create a virtual table on top of it into your local repository, into your local schema, and once you can drag and drop and combine the data. Like here we have combined the current data from HANA system and historical data from the maybe some other Sybase system, and combine them together and to get the data. So another thing is like how the structured data and the unstructured data will be connected. So earlier the structured data was getting siloed from unstructured data, and big data is also was getting moving away from the enterprise data. So this is one tool which brings up both the silos, both the different sets together, combines them together, and we can work on the common goal that, okay, we want some big data insights by using the enterprise level data. So earlier, instead of doing a business intelligence on the enterprise data and the querying on the unstructured data from big data, now we can do all of these things together. So we'll start with another unit, that is your unit 7, that is your reporting. So in this, we will see about the running applications on SAP HANA. So after we have completed this unit, we'll be seeing that how we can use business objects tools and how we can use different tools to connect to HANA, how we can build a small report, how we can use ODBC connections to connect business objects in SAP Office, and how we can use the dimensions and measures from HANA and business objects. Okay, so how we can see Lumira, one of the new tools from SAP, and we can connect Lumira on HANA models and create a dashboard or a storyboard on top of it. SAP HANA is bilingual. That means it can process two different types of queries. It can process normal SQL query, so which are basically used for transactional and analytical processing, and another is your MDX queries. MDX queries are only used by analytical applications. It is not used for writing data to the database. So SQL is a widely popular query language. That means it is almost used in almost every application. In every database will use SQL or PL/SQL or their own version of SQL. But MDX is very specific, and it is mostly used with your Microsoft-based applications, and it is not mostly used for writing the data back to the application or writing the data from the application. However, there is one advantage when we use the MDX queries. It is very easy to form a complex queries on hierarchies, and it is easy to form a multi-dimensional query with simple syntaxes compared to SAP HANA SQL. So SQL can be written to query along 2 dimensions at a time, but MDX can be written to a multi-dimensions at a time. So you have to write your context, then dot one entity, dot another entity, dot third entity, and so on. But in that case, in case of SAP HANA, you cannot have more than 2-dimensional data in using your SQL queries. Okay, so examples are like S4 HANA uses SQL as its communication language between the applications, whereas Microsoft Excel uses MDX as its communication language with SAP HANA. So based on the requirement to requirement, the languages will be different. So now this is the architecture for connecting different applications to HANA. So you have in your HANA box, you have your HANA tables, row store, column store, and some of the views which are created. Now, what are the different types of applications which can connect? You can connect the business intelligence application, the reporting layer, to the views which is coming from your sysBIC schema using SQL, MDX, or BIX. Then you can use your browser. So when you are building any application on HANA, then your browser can access the data from HANA using XSJS. XSJS is a lightweight server which runs in HANA and which enables the further development of further database development. Third layer is your SAP applications like your S4 HANA, then your SAP Vora, then your Fiori, or your any new applications which can connect with HANA database. It will also trigger SQL queries. Now there are different types of middle layer APIs, or what I'll call as middle layer connectivity options, which helps these applications or browser or reporting layer to connect with HANA. So these are called as the middle layer interfaces. You have first one is called as ODBC, that is Open Database Connectivity Option. Okay. Second one is JDBC, that is Java Database Connectivity Option. Third is ODBO, OLADB for OLAP connection, and BICS is Business Intelligence Consumer Services. So these are basically the 4 interfaces which will allow these applications to connect to SAP HANA, retrieve data, and send it back to the application. The question arises, why do we need reporting? So reporting is needed because to present your analytics, present your business requirement, and based on your business requirements, you want to perform some decision-making capabilities, or you want to analyze some set of data to arrive at a conclusion, or you want to see how my data can look nicely on a dashboard rather than simply seeing a set of data. So reports are basically any comprehensible object which are created on top of the tables to represent the information in a much more meaningful way. Now there are different needs of the reporting. Like reporting is if I want to access and transform the corporate data from the tables into a highly formatted charts and analysis for presenting to the higher management. That is called reporting. Then I want to visualize the data for better decision making. That is mostly the dashboard and visualization. Interactive analysis, if I want to answer some ad hoc questions and interact with the information. That is interactive analysis. Advanced analysis is you want to determine a trend or a comparison, or you want to see in specific complex charts and so on. So for that we have advanced analytics. How do I find answers to immediate business questions? So that is called as data explorations. I do not know the questions now, but I can create this and also answer certain things which might come up. So these are the different requirements of the reporting, and based on each of the requirement, different tools are created to address the problems over here. So from a reporting perspective, they are broadly classified into three areas. One is your normal reporting, second is your dashboarding application, and third is your agile visualization. Your normal reporting is your enterprise application reporting like PO, Crystal Report, Web Intelligence, Desky or Desktop Intelligence, and so on. So these are generally considered as the reporting areas. Second is your dashboards. So dashboards are basically much more formatted reports which represents the snapshot of the data, summary of the data, in which you can do a lot of interactive play. So like you have SAP Design Studio, SAP Dashboard, and Bex Web or WAD Application Designer, that is the WAD. Third category is your Agile visualization. Nowadays SAP and everyone is moving to Agile visualizations because they're much more meaningful to present. Second, they can summarize a huge amount of data in a smaller area, and you can also perform the what if analysis. You can also add a lot of meaning to the report which you have prepared. So some other tools are like predictive analytics, Lumira, Explorer, analysis for MS Office, analysis for OLAP. So these are the tools which you can check as part of your Agile visualization area. Now let's see. We have SAP HANA database and how these different tools connect to SAP HANA database. So MS Excel, it uses the ODBO connection. So ODBO connection, I'll come back again, and it triggers MDX queries instead of normal SQL queries. Then you have Crystal Report 2011, 2008, 2013, which can connect to SAP HANA database directly through SQL. Then you have Explorer. So Explorer is a tool, web-based tool, which is used to capture the data and also to see how the data behaves, or how the data behaves along with the different parameters. It uses the JDBC driver to connect to HANA database. Next, we have different tools, a new set of tools like your Analysis Office, Visual Intelligence, now called as Lumira, then Design Studio. All these different tools use Bex to connect to the HANA system through SQL queries. Then we have another business objects tools called as your Web Intelligence, Crystal Report, and Crystal Report. And this interact with SAP HANA through a semantic layer. This semantic layer is called a universe, and this provides an additional benefit and security level of data. This semantic layer interacts with SAP HANA through a bridge of JDBC and ODBC, and it triggers on your SQL queries. So these are the different interfaces or the drivers which allow you to connect to SAP HANA database. So the first one is overly ODB or OLE DB for OLAP. So this is OLE DB and for OLAP. This is a Microsoft based driver which was developed earlier for object linking and embedding. So earlier it was known as So you would have seen that when you copy from one Excel to another Excel or one Excel to Word or even to your Outlook, that time if things do not go well or if the Outlook doesn't work well, then you might see that OLE object not found. Okay, so this is how Microsoft enables a communication between all the different tools. So like ODBO is basically this enhancement for database and for OLAP. So if you have OLE DB, so it is OLE for DB. One, it was enhanced for OLAP or for the faster read of the data. So it became ODBO. That is OLE DB for So the queries which are used is MDX queries. So MDX queries are in multi-dimensional queries which are used to retrieve data from a multi-dimensional objects. ODBC is an open database connectivity option. So it is again a Microsoft provided driver. So data requests are made via SQL instead of in your MDX. Okay, and this is one of the most heavily adopted driver in the industry. And sometime back it had become Microsoft independent. It was able to support Unix and Linux drivers also. Third one is your JDBC, that is your Java database connectivity option. It functions similar to that of ODBC, except that it is limited only to Java-based applications. Then you have BICS, that is the Business Intelligence Consumer Services. So this is your SAP proprietary driver that offers advantages on OLAP server and is very fast to connect. The last one is your MDX. It is basically your multi-dimensional reporting objects. So this is a driver technology used by SAP Business Objects Analysis, Office Edition, and the semantic layer loaded business objects clients, mostly on the SAP NetWeaver category. The classification of the reporting tools have become converged to much more smaller areas now, like Crystal Report, Web Intelligence, and Desktop Intelligence has been converged to Crystal Reports and Webby. Desky is gone now. Predictive, Lumira, BO Explorer, Analysis for OLAP, and Analysis for OLAP are as one segment, which is discovery and visualization. Then you have SAP Design Studio, SAP BO Dashboard, and VEX and Web Application Developer. All this will get converged to Design Studio. So we'll need to see that what are the latest tools which you should learn so that you're not lost as part of the old tools, like your dashboard is not very much frequently used, but instead we have Design Studio.
SAP Design Studio is designed only for OLAP, right? It can be, I never used Design Studio, but it can be used for ODBC, right? For the normal traditional RDBMS.
Here, if you can see, we can connect via ODBC also. Design Studio, your business objects tools can connect via ODBC as well.
Yeah, so we can connect through direct to ODBC, or you can direct connect through the semantic layer, right?
Yes. Crystal Report and Web Intelligence can now connect directly to HANA. It can also connect through an extra semantic layer also.
Right. Okay, so finally, for connecting SAP HANA, whether Crystal Report Design Studio or dashboard will be through the ODBC driver, not through
Yes.
any. Okay, they are not. We are not having any native drivers for SAP HANA.
These are the drivers which are from HANA itself.
Okay.
I'm talking about these are the drivers which needs to be installed in the local client, local server in which we will be working.
Okay, so ODBC means, so normally ODBC is a third-party driver, but we are referring here ODBC as a native driver.
Correct, correct. Okay, from the native driver, what you say is from SAP side. So
Yeah.
from SAP side, we have BICS, that is the Business Intelligence Consumer Services.
Okay.
So only the new tools like your Lumira Analysis Office Design Studio can connect to HANA through BICS. Your business objects tools, your other tools
Correct.
can connect to ODBC or ODBU.
Yeah, that's what the selling point here, because other tools, right, compared to other BA tools like Cognos or MicroStrategy, so this one is a selling point for object. Why business objects when HANA is there? So that's the big advantage. So the reason I'm asking, currently a customer is also analyzing SAP HANA versus Cognos. Why Cognos? So what is the advantage we are going for business objects? So that's what I am doing some analyzing and proposing the solutions. Currently we have a lot of tools at current client, and SAP HANA is going to come, and they are trying to decommission other tools to keep business objects.
So BICS is a native connector for not for WebJ but only for few tools. So still from the business objects portfolio, from the BIP like Web Intelligence or Crystal Report, they connect through a semantic layer, or now we can directly connect to HANA. So here you can see BICS is an SAP proprietary tool. So, and in fact, even if ODBC and other things are there, so there is no issues that we don't have to worry much about, because whenever there is an installation, there will be installation of this client as well. And SAP provides this client interfaces along with the installation of SAP HANA Studio.
All right, let's test your knowledge. Here's a question for you. Which of the following is not a benefit of single container multi-tenancy in SAP HANA 1.0 SP12? Option A, reduced hardware costs. Option B, simplified administration. Option C, isolation of tenant databases. Option D, increased network latency. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, ready to dive into the world of SAP HANA 1.0 SP12? Our course is your ticket to mastering supply management. You can learn at your own pace, right here on our platform. In this course, we will unpack SAP HANA 1.0 SP12, the ultimate toolkit for planning everything, from ensuring we have got enough products to get them where they need to be. Covering everything from the basics to advanced techniques, our course is crafted by seasoned experts who know their stuff. Your instructors? They are pros with years of experience, dedicated to helping you learn and answering all your questions. And guess what? Our students love it. Just like you, they have found our course incredibly helpful. The best part? It's super affordable. This amazing opportunity to learn won't break the bank. Ready to become a SAP HANA 1.0 SP12 Pro? Sign up on our page now. For more info, visit ZaranTech's website.